welcome to AWS Community Day. We're super excited. Here with me, I'm Peter Hansons. Here with me, I've got Helen Anderson all the way from Wellington, New Zealand. I'm a Sydney-based AWS serverless hero, and we're here for the Data Day track, which is super exciting. So my claim to fame is that I run a couple of meetups. So you probably see me around at the serverless or data engineering meetups in Brisbane, Sydney, and Melbourne. I've run a couple of conferences this year as well. You might have seen me there. AWS Serverless Community Day. We did a data engineering community conference called Data Eng Bytes, as well as Serverless Days ANZ. So serverless data engineering, they're my jam, and that's kind of what my main interest in life, or not completely in life, but in my career is really the intersection between serverless and data engineering, and how it's becoming more and more serverless. So yeah, that's I'm super pumped for the talks today. Um, hey Helen, how about you tell us a little bit about yourself?
Yeah, cool. Hey everyone, I'm Helen. I'm a New Zealand based AWS data hero, and I'm coming to you from Wellington, New Zealand. I'm passionate about all things data and analytics. You can find me blogging on Dev2 about data and BI, and I also moderate the SQL and database tags. And I spend too much time on Twitter talking tech and sharing articles. I'm really keen to hear our speakers today. We've got some exciting things coming up with data warehousing and data lakes, which is right up my street. Yeah.
Cool. So before we get started, we'd like to do an acknowledgement of country. So on behalf of the organisers, I'd like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to the elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today.
Nice. Cool. We also have some housekeeping bits and pieces to take care of before we kick off. So we are a welcoming community, and everyone should feel really comfortable here as they are, which means that we don't tolerate any harassment in the chat. And if we see any breaches, we'll be moderating that. If you see any breaches, please let us know. We have an email address that you can find us at awsanzcommunitydays@gmail.com. Like I said, Peter and I will be in the chat, so please feel free to ask us any questions, get to know each other. That's what these events are all about, and we'll be keeping an eye out for any questions for our speakers. So get involved, log into Twitch, and ask your questions. They might be asked after our speakers present. Cool. And with that said, I'm keen to hear about where everyone's from. So let us know in the chat if there's any Kiwis there. Big ups to you guys.
Yep, love New Zealand. I was saying to a few of the folks in New Zealand, for part of my honeymoon, I drove all the way from Auckland down to Queenstown, and got to see a good slice of the country, and it was
Nice.
really awesome. Such a wonderful place. If you're from a big city, perhaps you can tell us like which region of that city. Like I'm from the inner west in Sydney myself. Shout out to any of the data engineering folks that are from around here as well. Awesome. So we'll change tracks a little bit from some of these sort of general announcements, and I guess telling you a little bit about what's in store for today, and take you through a little bit about, I guess, some of the themes that we're seeing as heroes in the data space with AWS, and because I think what we've found, especially doing the selection of the speakers over the last couple of weeks, and so many great talks were put forward. It would probably take a conference the size of a week or something like that just to get through and cover every AWS data service, let alone every AWS service there is.
Yeah.
There's just so much happening in the data space, isn't there, Helen?
Yeah, totally. Yeah.
Yeah, so I guess some of the themes that Helen and I have both seen developing in this space is that what's happening is there's a lot less custom code and infrastructure being developed by data engineers. Data engineers, well, perhaps that's a broad brushstroke, but definitely data engineers and data folk are tending towards using more managed services and writing less custom code. Definitely looking at SaaS applications, data engineering as a service, and things like that. So that's one of the major themes that we're seeing. Also, more and more folks are using real time streaming. Some folks, to be fair, that's all they do. Like, batch is such a minor part of their infrastructure. And then some of the more traditional folks are really starting to embrace real time streaming in a big way. Also, what we're seeing, and this marries up quite well to the AWS database offering, is that there is a lot more variety in the database workloads that we're seeing coming through. A lot of folks are starting to, because managing databases and the like is becoming a whole heap easier these days. I think it's giving that headspace to go out and experiment a bit and perhaps try a graph database to handle some of your metadata and data lineage, concerns and things like that. So that's super exciting. As well as, I think what we're seeing is that data is obviously becoming more serverless. That's probably very self-serving for me, being a serverless hero, but I think everyone's kind of tending towards that way. I'm seeing a lot of third parties looking like that as well, which is really great because it just frees up data engineers to get on with the more value adding aspects of building out a data stack, as opposed to just spending all their time managing and patching servers and stuff like that. So what's happening in data in terms of databases? Well, AWS have got things like Neptune, which is a graph database. And as I mentioned before, some of the use cases can be data lineage and use cases for metadata tools. At the Sydney Data Engineering meetup, we had one of the founders of Amundsen come and talk to us. That's an open source project that's come out of Lyft. That's really cool. A few customers are starting to look at quantum ledger database, and that's really around use cases where you're wanting a tamper-proof database. Think of torrents titles, or motor vehicle registrations, where you don't want someone just randomly changing who owns a particular parcel of land or a motor vehicle or something like that. It's also Amazon Key Spaces, which is managed Cassandra, that's completely serverless, and also TimeStream, which is a time series database, which is really cool for consuming all of the data coming out of your IoT workloads. What's happening in data integrations? Well, there's a lot of folks really embracing EventBridge. It's not just a application engineering tool, definitely as an event bus for use in your data stack. That's definitely a really cool service. AppFlow, when you're looking to integrate AWS with things like Salesforce and have two-way data integrations, Marketo and things like that. I think AppFlow is a fascinating low-cost way of taking a lot of that custom data engineering code off your hands and just and using that service. If you do want to run your own Kafka cluster, MSK takes a lot of management overhead off you. But then, of course, you've got the serverless Kafka offering, which is Kinesis. And recently what was announced was retention of 1 year of data, and that's just been announced. So that's a super exciting development in that space. And then, of course, step functions for orchestration. I think in data engineering, step functions are becoming much, much more prominent.
Mm-hmm. Totally. So I guess from the analytics point of view, with the number crunching happenings, I'm seeing a lot more take up of federated queries. So not just Athena, but the Lakehouse model, using Redshift and Athena to really change the game for analysts and scientists. It's hearing a lot of good feedback that they no longer have to wait for data engineers to move their things around. They can just get started straight away. So that's really exciting. Redshift also launched the RA3 instance, which allows us to scale up and down compute and storage to get more bang for our buck. I'm seeing a lot more of that happening in the community. And I've been seeing more people using QuickSight, especially for augmented analytics. Those things like churn models and lead score and forecasting and that kind of thing that, maybe you'd get a data scientist to do some machine learning magic traditionally, but now you can just plug in SageMaker and you're good to go. So that's really exciting.
Awesome. So, also, there's a lot of developments that have been happening in the data lake side of town. Obviously, we've got AWS Glue that's been around for a couple of years to do all of your cataloging, transforming, and scheduling of jobs. I think lake formation is a fascinating development in the data lake space. A lot of the heavy lifting. Think of lake formation if you wanted to sort of, I guess, try and conceptualize what it is if you've never heard of it. It's like landing zones for data lakes. It's taking away a lot of the heavy lifting of rolling out that basic security and IAM infrastructure for you, so that you're not really having to sort of reinvent the wheel for each company that you go to. So AWS have kind of packaged up all the best practices of, row level permissions and things like that, so that you can just kind of sort of spin all of that up and get it running. So shout out to Syed Jaffrey and AWS Solutions Architect here in Sydney, that's come along to the data engineering meetup a few times to take us through that. I think we've found those sessions invaluable, and of course, let's not forget. I think a big theme happening in data at the moment is metadata, data lineage, but also just around search, discoverability of data. I think what a lot of organizations are missing at the moment with their data lakes or data swamps, as a lot of folks are referring to them these days, is that what the heck even is in there? How do you even get to it as a business user? What, where's the discoverability? And I think AWS, obviously have got Elasticsearch there, and I think they're doing a lot of innovation in with their open distro. So that's really cool. So awesome.
Yeah, lots of exciting stuff going on in the community, and new features coming out from AWS. I'm really excited about reInvent coming up in the next few weeks. This year, it's going to be all virtual, all online, so we all can join. So folks who generally don't get over to Vegas, like us down in the Southern Hemisphere, can get along and see the keynotes. This year, it follows the sun. And what that means is that the keynotes will be recorded and we'll get a chance to see them in Singapore time and GMT time. So get the team together, book a meeting room, hang out over lunchtime, see those announcements, really cool. For us in the data world, there are tracks for databases and analytics. And this year there's a BI track, and I'm not sure if this is the norm, but really interesting for me. So looking forward to hearing more from the BI side of things.
Yes, and stay tuned for some local announcements in and around AWS reInvent from your local community heroes, which will be really good fun.
Yeah.
So before we dive into our first talk of the day, just like to ask the Twitch stream, what's your favorite data service? Like, there's so many of them. What are you sort of having a play around with at the moment, or sort of getting your head around it, or having a bit of a struggle with? Let us know. It's fascinating to hear what you're building with the data services on AWS. Very cool. So now, with that out of the way, our intro and welcome and all that to this very cool data day, we'd like to introduce our first speaker, which is none other than Corey Quinn. He's going to be taking us through Route 53 as a database. Now, correct me if I'm wrong, Helen. Did we cover Route 53 as a database during our overview of the data services?
Yeah, well, it's so common. I don't know why we didn't cover it off.
Must have
What
slipped
the
your
hell
mind.
is wrong with people in Australia? Route 53? No, it is Route 53. Please. You've also been talking about databases, whatever those might be. Most of us call them databases. Let's just agree to all be wrong, call them dirtaburses, and suddenly everyone's unhappy. Why not?
Hilarious.
Yeah, so I'll be ranting for a little bit, and then you can come back and feel free to throw questions into the Twitch chat. The second half of this basically becomes an AMA as it devolves into chaos. See, I'm in San Francisco, and it's still Sunday here, Sunday afternoon. The sun isn't even down yet. So you're getting weekend ridiculousness, not weekday ridiculousness, which is a little bit different. So we'll see how it winds up playing out. Oh, someone's already called out I have the COVID man bun. Yes, I do. It was either that or shave my head, and I look like a giant walking schlong. So there's really no good way to solve this. Either way, I look silly. This way, I get to experiment a little bit. But we'll get there. As mentioned, I am Corey Quinn. I'm on the Twitters as Quinny Pig. Some of you may be familiar with that. I also write the Last Week in AWS newsletter. That's lastweekinaws.com. Check it out if you haven't. You'll regret that you did. As Helen mentioned, reInvent is coming up soon, AWS's own version of Google Cloud Next. And Google made their ridiculous thing, basically the psychotic cloud groundhog from hell, where it's going to be 9 weeks of videos that we dump every week. And it's awful. But AWS looks at that and says, we can do a shittier thing than that. So they're doing this for 3 full weeks. It's basically like the last 5 days in the United States have gone stretched out, where no one can tear themselves away from the train wreck currently unfolding in front of them. And they think it's going to be okay, but they're not sure. I'm going to be doing something vaguely similar and sarcasming my way through the entire event at a place called Requinvent. That's right. Requinvent.com will have my ridiculous nonsense ready to go. So, yeah, 3 weeks of that is going to be nonsense. But that's not what this talk is about. This talk is about using Route 53 as a dirtaburse. People take all kinds of different approaches to that. Musical accompaniment.
And Route 53 is into database. While I'm here singing this song, Army has only 2 syllables. I disagree and commit when I'm wrong.
Yeah, so we've talked a while now as a running gag about using Route 53 as a database, only it's not really a running gag. It can be done. Text records in DNS are incredibly versatile. That's sort of the entire point. Now, regardless of what you say about things like Istio and various other forms of service mesh, they all more or less do the same thing of pointing different things where they need to go. And most of these things are riding on top of DNS. Well, DNS is incredibly extensible. So I started talking about using it as an inventory management system, and half of Twitter looked at me like I was insane. They're not far from wrong, but I'm also right on this. But they're turned into, I guess, some interesting conversations, and they're right. There's not a whole lot of relational data models that work out as well. Not every piece of data winds up working in a Route 53 schema. So this sort of led to an interesting question of what else can we do with AWS? Now, Ben Kehoe, a community hero, I believe. He might be a serverless hero. He might be a robot hero. All we know is he's extremely AWS heroic. And I have been going back and forth for years now on what he terms PackRatDB. Namely, how much data can you shove into an AWS account for free? So I started doing some numbers on this, and it's surprisingly high. Because the easy starting point everyone goes with is great. You get 75 gigabytes of storage in Lambda in every account that they don't charge you for. And that's awesome. Some lunatic on Twitter at one point came up with this great model by which you could use that as a streaming video source. And you probably don't want to do it, but you can. And by the way, everything I'm about to say probably violates every term of service they have. Don't actually do that. But then I started going through the obvious stuff, like, okay, every resource you get can have a tag, up to 50 tags per item. How much data can you shove into tags? How does that key space wind up evenly distributing things out? But then I started doing actual math, because you also, in the AWS free tier, across a bunch of different services here, wind up getting it a few other places, like 20 gigs of data for free in RDS, 5 gigs in S3, 25 gigs in DynamoDB. We have Richard in the chat saying 75 gigs per region. That's not actually called out anywhere, mind you, in the AWS docs. So I'm trying to wind up being a little bit more, I don't know, objective on this. Another gig in Cloud Directory, 10 gigs incognito, 5 gigs in EFS, 30 gigs for EBS, and so on and so forth. But the thing that really tipped it over the edge here was that you wind up getting 30 days of a free trial with 1 terabyte of storage per user for WorkDocs. And you get up to 50 users free, which means, I do the math, you're getting slightly under 54 terabytes of data for free in every AWS account. Take it a step further. If you really think about this, you're also able to get up to 4 AWS accounts in your AWS organization before asking for a limit increase. Now, fill an AWS account with all of this nonsense, and suddenly you're going to have some interesting questions to answer when they ask why you want to add more accounts. But that's neither here nor there. So at that point, we are a little bit over 200 terabytes per free AWS account without ever having to talk to AWS about anything. You can stretch this and put it in a few other directions, and it starts to get really interesting, really big. But there's more, because how in the world are you going to take all this data and get it out? Remember, data in to AWS is generally free. Data out generally costs a king's ransom. There are 2 key ways you can get data out that work for everyone. The first is, surprisingly, is Amazon Chime. There is no data transfer cost to shove data in text form in Amazon Chime, and there's no documented limit as far as how back in time the chat log will go. Now, certainly there's going to be someone looking at this and asking questions, but they really should have put a warning on the label if they didn't want us to misuse it that way. That's the easy way. For super large scale data, we're talking in the many petabyte region. We're probably not going to want to shove all of that into Chime. I mean, Amazon Chime is certainly not going to want you to shove that into it. And it's going to stand out super well because this is Amazon Chime. It's not like they have customers. So as soon as you start using anything like this through Chime, it's going to show up massively and horribly. So how do you get data out without breaking the bank? Simple. You shove all of this data, or as much of it as you possibly can, into S3 as a general rule. Then you come up with some absolute nonsense reason to sue AWS. It doesn't really matter what you're suing them for, but as a part of that lawsuit process, you demand access to all of that data as a part of discovery because it's going to clearly prove your case and exonerate you. So when they deliver all of that data to you, maybe printed on paper in the back of a truck, we don't know, but again, work with me here. Suddenly you've gotten your data and they're not going to charge you for it. That is that little secret that AWS doesn't want you to know. So as a general rule, that's where I've been thinking lately around fixing AWS in strange and interesting ways. There are other areas that I didn't get into that they don't actually document as far as places to store free data in. Honeycode, for example, has a limit of, I think, 100K per table, or 100K items per table. It's not clear exactly how much data you can shove into that, and it's Honeycode, so it's not exactly great to begin with. But all that is to say, there's a whole bunch of places you can shove data into. Hell, you can take it a step further, binary encode these things, and then wind up storing it on an hourly basis by making API charges and then pulling it out of the cost and usage reports. Now, the best part of all of this is, so you've managed to shove, the better part of a petabyte when all said and done into free AWS storage. Wait a year. At the end of that year, you are going to be charged so much money for what you have just been riding for free that it's not even close. We're going to be talking tens of thousands of dollars a month. It's a very vast gulf between what's free today and what's not free tomorrow. Some of these things have a 30-day free trial. Some have 60 days. Some have 12 months. And some are free forever. Why? Because honestly, there's no rhyme or reason to an AWS bill. That mostly covers the insane rant I wanted to cover. We're going to turn the rest of this into something approaching an Ask Me Anything session, or are you serious with anything that you've just said? Sort of, kind of, maybe, All right. Hosts, take it away. What can I answer for people? I haven't been paying close attention to the chat, so I'm assuming people are just piling insightful architecture questions that I can help solve their production problems with solutions like this. Remember, modern cloud problems require modern solutions.
Okay, well, that's really put us on the spot.
I
Helen,
did.
handball it over to you.
Oh.
No, let's. Oh, we've got Adrian Cantrell on the line. Who else have we got? Richard Boyd, all the way from Boston. Very cool.
Oh, I don't know if I'd ever say that anything coming out of Boston is cool, but I used to live too close to there, and I might have some prejudice that still lingers.
There is.
Low blow.
It does look like Richard was correct. There is, in fact, 75 gigabytes of function and layer storage per region. So now that there are, 24 regions-ish that you can wind up hitting, that becomes significantly larger. You're right. I missed a whole bunch of free storage space. Good job, Richard. I will give you credit on the service ticket that I wind up filing when I start having problems.
Robert Tables has asked if you roll a new count under an existing organization, does that fall under the free tier, or do you get a new set of free tiers with that account?
There's one way that it does count as a new set of free tier, and I see it periodically on my own thing, which is nuts. I don't remember whether it's the take an existing account that you spun up separately and shove it in, or if it's the provision something new with Control Tower. One of them works, one of them doesn't. So test it before you shove the better part of a petabyte into that new account to see if you're getting charged for it. But yeah, there is a way to get basically the eternal land of free tier there. One of the benefits by doing this, incidentally, is that it keeps your data mobile. It doesn't wind up sitting still for very long and gathering dust, because if it does that, you start to get charged for it. So you need to continually move this thing into different various different accounts so you can stay within the free tier. For those 30-day free tier things, that can be a lot. That can be basically constant movement. When the data spends more time living on the wire than it does on disk, that's called a storage area network. When you start running out of storage, what you have to do then is wind up putting things further away so that you can send all the data before it comes back. You can do this with both physical distance and, of course, longer cables.
Hilarious. Helen, help me to any insights on COBOL, Corey?
Yes, apparently it's a great way to print money because no one uses it except, surprise, everyone uses it, but for some reason they never teach it to people nowadays. There are some companies like IBM who are big fans of COBOL just because they still think it's 1970 in basically every aspect of their business. But it is the sort of thing that runs this one weird workload. Oh, so what workload is that? Oh, the entire ATM network. Or, yeah, that thing that makes all the money, that calculates risk, and we're an insurance company. It lasts forever, and you can never get rid of it because no one knows all of the things that it touches. I have seen people shove COBOL into Kubernetes, which is just basically crossing the streams awfully. But what I really want to see is COBOL inside of AWS Lambda. The 15-minute lifetime might be a bit of a problem there because, honestly, who can do anything in 15 minutes if COBOL is still something you're working with? But that's neither here nor there. I think the technology is going to be awesome. Hey, someone says that they've seen COBOL in Lambda. It was awful. Oh, I was predicting it was going to be this great thing that somehow we would have worked out magically. Like, there's no way that story was going to end well. Get serious. Of course it was awful.
So, Helen, we've got a question from Ian McKay. Did you want to read that one out?
Yeah, so if I'm reading it correctly, it's how much data can we squeeze into tag keys and values?
50 key, good question. The actual limits, I want to say it's, someone will correct me on this, but this is why I don't do things off the top of my head. 50 tags per item, and then you can wind, I don't remember what the key size was, but the tag size, I want to say, was 256 characters. Please don't quote me on that, but I'm sure that'll be hilarious. Remember, you can also pre-compress all this data, too, before you start splitting it across the entire key space. Beyond that, it goes even further, because it's then listed, because tags are free. how many resources can you shove into accounts? Because think about this. You have IAM users, which cost you nothing. You have IAM roles, which cost you nothing. You have all these different things you can spin up, like security groups. They don't cost you anything. VPCs, they don't cost you anything either. But for God's sake, don't put a managed NAT gateway in there. That's going to start costing you all the money. Don't have unattached EIPs, or suddenly your attempt to scam a bunch of free data storage out of AWS gets completely shattered when they start billing you for these things. I mean, please, let's keep our eye on the prize here. But yeah, you can wind up effectively shoving a tremendous amount of nonsense. Hey, okay, and there's Richard, obviously cheating by reading the documentation. 127 characters for the key, 255 characters for the value. But is that 255 counting in geek starting at 0 or not? I'll let him try it and see.
Very cool. Yeah, perhaps base 64 encoding some of those values, perhaps. Richard's also asked, how much data can you store in Snowball Edge, for instance?
If you get a Snowball Edge for free, that's a whole separate argument, but you've never been able to get one of those for free. So I sort of didn't look into that at all. You can shove 50 gigabytes of data into code commit, though, which is like GitHub, except nobody uses it.
Very cool.
50 gigabytes of storage on the database migration service, for God's sake. Where are you migrating data from? Oh, between AWS accounts, mostly.
Do you know how organizations work with the free tier then, Corey?
Surprisingly poorly is the short answer, because the documentation says that in an organization, one account counts as free and that it extends to all other accounts in there. In practice, that's not what happens on the bill. I still get free things spun up in my test account whenever I launch one. So it's, oh, cool, my first gigabyte of storage in S3 or 5 gigabytes of storage in S3 are not charging me. That's money. That's relevant. That's, it's who cares money for the most part. To be blunt, I'm not super deep on the free tier because this may surprise people. When I go in and fix companies' AWS bills, how much are we able to fit into the free tier is, to date, not a single customer has ever asked me that question.
Ooh, interesting.
Yeah, it's always the big number. It's like, oh, great. When you're spending, $50 million a year on AWS, it's hard to start doing surprising things to the bill. The model changes, because if I drop my credentials onto GitHub, for example, or GitHub, depending upon pronunciation, and someone starts spinning up a shit ton of things to wind up mining Bitcoin, great. How do I see that? Well, my bill went from $37 a month to $18,000. Cool. I'm going to see that. How much Bitcoin do they have to mine to move the needle on a $7 million monthly bill? Pretty much all the Bitcoin. It's harder to see these things. The bill stops being a good early warning system when you're no longer in small number territory.
So getting on to, I guess, you're a cloud economist. You see a lot of customer bills, and generally speaking, in a state that probably where they need a bit of optimization, to probably put it politely. What are some of the most expensive mistakes that you've seen on an AWS bill? Any cool stories coming out of that?
Sure. It's stuff that you probably would see a bit differently. You've got this entire nonsense world of people thinking, okay, I'm going to build this complicated system that dynamically scales up and then immediately scales down my development environments. But then you look at production environments and no one's bought an RI for 18 months. No one's heard of savings plans, and people haven't done any baseline optimization. You have 5 petabytes hanging out in your data warehouse. Who wound up spinning that up? Well, the answer was someone 8 years ago who then left for another job and no one ever bothered to delete it. So it's the big money wasters are never the exciting, intricate, one weird trick Andy Jassy doesn't want you to know. It's this 15,000 little things that, oh, you mean I should turn things off when I'm done using them? Huh. Wow. It never would have occurred to me that a security breach could get expensive. What the worst projects are the ones that do become expensive and become these security projects I didn't expect to have coming, where it's, okay, let's talk about your instances in Australia. Or sorry, you folks are in Australia. Let me back that one out. Okay, let's talk about your instances in the Mumbai region. Great. We don't have any instances in the Mumbai region. I believe you are being sincere when you say this. However, the billing system then says, and yay, we're mid-security incident. Why? Because everything's terrible. I would like to point out that there is no inventory that is available to us, first party, other than the bill of what's running in your account. And that bill is 1 to 4 days behind what's currently running. Welcome to hell.
Amazing.
Yes, things can get pretty wild pretty quick is, I guess, the outtake from that, especially if you're on a 4-day lag. So we
That's like
had
mailing it to Australia via the post latency.
pretty much, especially in the COVID era, it is pretty wild. So look, getting things back on track. Satalt09, if I've completely mangled that name, apologies, but I guess he's a very your typical data person, very black and white. Maybe I misunderstood the topic. Can we actually use Route 53 as a data store? And I hope I pronounced that correctly.
No, very, very fair question. I want to be clear on this because this whole running gag of using Route 53, AWS's DNS service, as a data store started with something that I did legitimately many years ago, where we were running effectively physical machines or virtual machines with containers on them, where we wound up having to list, well, that service or that node, what physical machine does it live on? And we stored the answer to that in text records. We were fundamentally using DNS as a configuration management database. And I posted about this on Twitter, and a few interesting things happened. First, most people said, that's awful. Other people said, is this something I should be doing? And let me drop the joke for a minute. No, there are way better tools for doing this sort of thing. Tags, for example, for God's sake, use tags or a legitimate configuration management system that is designed for this. But far and away, the best response I got was in a DM from someone where, look, until a year ago, we were doing this where I work. So apparently this is not just this crazy thing that you built. This is something that is actually widespread. So I looked him up on where he worked, and buddy, that's where I worked. I built that insane monstrosity, and you're telling me it was still there until last year? That's amazing. And then he asked me to please not disclose where this was, and let's not kid ourselves. I'm not here to make people's lives worse. But yeah, it's so bad that people started legitimizing it, and then I realized, I should probably back this up a bit. But yeah, you can use tags. You can use DynamoDB. You can use a bunch of open source projects that wind up helping solve this problem. But partially this is what service discovery is for as well. And the problems we were trying to solve back then aren't really the problems we have to deal with today. Back then, it was problems such as, okay, we have the primary and we have the replica as virtual machines. That's great. Could we maybe please not put them on the same physical host for a variety of excellent reasons? So being able to have some terribly broken bash scripting that did some placement logic around this was why that whole thing worked, because we could hook DNS from anything. Now, there are way better tools to do that, but that's where the joke came from. Please don't actually do this. It's funny, it gets a laugh, but if it's something that starts going into production, you probably have gone off the rails somewhere. I'm all for a good joke. I'm not for getting people fired most days.
Yeah, that makes total sense. So, look, you've recently became a father again, and so tell us.
Yes, Dad 2.0, Dad harder.
Yes, tell us a little bit about that. And is it like working with CTOs?
No, because when you change the diaper, the baby stops crying as a general rule. It was weird because it's the first time the first time I had a kid, it was great because it was this world-changing everything for me, where suddenly I went from being not a father to being a father. The transition the second time was nowhere near as big of a gulf for me personally. It was harder in the sense of originally I could go and hang out with friends and people would come over and visit the baby. And now we're in a pandemic, as you can tell by my man bun. And it's not nearly the same level of interaction. I'm basically trapped at home watching the baby with no one else around. And it becomes a little bit grating. The days start to look all the same. And being on paternity leave for that period of time, in many respects, was kind of boring. Infants, for those who are not aware, are not the most entertaining little slugs in the world. They kind of just sit there and cry and eat and sleep. And that is pretty much it. Plus pooping. So yeah, I don't really want to tie that back directly to CTOs. Maybe, I don't know, whoever's in charge of AWS naming, but that's a separate problem. Their service names, so good, so good.
Another left field question for you. What is the fastest way to lose money in AWS, and why is the answer NAT Gateway?
NAT gateways can be expensive, but that you're limited there to how much data you can shove through them. You have so that's 4.5 cents per gigabyte shoved through them. But depending on what you're sending to where to the outside internet, you can get charged more than that, but it has a nice doubling factor. The fastest way are probably going to be single one-off API calls, like enabling a, the Shield Advanced is a $36,000 a year thing with a single API call. But from a pure mathematics perspective, the most expensive single API call you can make is buying a savings plan. It's what is the amount of money you're committing to spend and over the next 1 or 3 years. And it's weird because what's documented in the service limit story doesn't really get into this. There's some JavaScript that prevents you from putting numbers above a certain size into the buy a savings plan form. And this may surprise you, but I haven't actually bothered to test it yet because I think the answer was like either trillions or quadrillions of dollars that you could wind up committing to. And I feel like they might actually hold me to that from a perspective of, well, look, no one is actually going to be able to buy this a lot if we market it, but it only has to work once. And we're the best company that ever lived. It's a hard sales problem. I don't know what the actual limit is. And for some reason, whenever I ask my friends on the billing team, they just make this whining sound and don't answer.
I think Richard Boyd, he said that you tweeted previously that a reserved instance R5 24 extra large enterprise multi-AZ Microsoft SQL Server instance.
The Microsoft SQL Server is more expensive than the Oracle stuff as well. Oh, someone just said don't know why the certificate manager is costing them $350, probably on a monthly basis. They have a private CA. They don't need it in most cases. If you don't know that you need a private CA and know exactly why, you don't. Get rid of it. It's one of those nice things to have, but it's hundreds of dollars a month for no direct benefit for most folk. Sorry. If I can actually help people and stop the jokes for a minute, I feel like I kind of have to.
Nice. Good touch.
The jokes are great.
I try because without the jokes, how boring is this stuff? Think about it. If it were Ben Stein from the Wonder Years reading off, and this is how you buy a savings plan. My God, I've seen that talk. It was at reInvent. I didn't like it.
You've mentioned you've got friends on the billing team. Have you got friends in the solutions architecture team?
Billing team is kind of a papering over of what really exists, much as Friends is a papering over of people's relationship with me. Yeah, there's a lot of people that do a lot of different things all throughout the various AWS service teams. They certainly know who I am on many of these teams. They're not necessarily all fans of what I do, but when you speak for the customers, they kind of are forced by a company policy to deal with you. So that it leads to interesting conversations. My honest take is that AWS is comprised of incredibly hardworking people who mean well and are doing a lot of really neat things. In the individual instance, all these problems are hard and all of these things wind up being difficult to solve for. But in the aggregate, just viewed as the actions of a $1 trillion company, they're hilarious. I try and lean into the idea of the big bumbling company making dumb decisions, not individual people working on super hard to solve problems. So I do try and keep this at a point where the jokes are funny and lighthearted and not making individuals feel like crap based upon what it is that I've just said. So if I get that wrong, first, I apologize. Secondly, please let me know because I don't want to keep doing it.
Nice. Cool. And where can people hear more from you?
They can find me on Twitter at Quinny Pig, QUINNY Pig, or, of course, last week in AWS.com, which is where I bring the funny every Monday morning in email.
Very cool.
Whether you want me to or not.
Well, thanks so much. There's been a bunch of more questions coming through. Some actually quite valid and serious questions about how to process data stored in S3 and what's the cheapest way to do that. But we're fast running out of time. But it's been hilarious.
I can hang out in the Twitch chat as well and address those if people would like to hear my thoughts on those things. In some cases, the answer will be, I don't know.
We'll
Nice
take it.
one. Well, pleasure as always. Thanks so much, and Corey, and we hope to see you in person, perhaps at reInvent next year or something like that. And
When it's no
don't
longer
miss
a deadly
Country.
risk, well, other than because I mouth off too much, I'll be there.
And you're always most welcome to come to an event here in Australia when we meet back in person after all of this COVID stuff is over.
Excellent. Thank you very much.
Cheers. All right.
Cool.
Bye. Okay, welcome back. Our next speaker is Sunita Mall. She's going to take us through Nearmap AI, the story of data creation to power all of the awesome stuff that Nearmap do with in the mapping space here in Australia. So Sunita is a principal machine learning engineer at Nearmap. She leads the data engineering team and is responsible for building and managing the systems that power Nearmap's deep learning model.
Okay. In her talk, Sunita is going to focus on how to utilize AWS services to build systems that allow them to create ground truth. This talk will also tackle how Nearmap grows and scales this dataset while managing the challenges around efficiency and quality. Sounds like an awesome talk. So we're going to roll the video now.
Hi, thank you for tuning in. Also, a big thank you to AWS and all the community heroes for organizing this event. I'm very excited to be here, and today I'll be talking about how we are curating data to power deep learning at Nearmap. I'm Sunita Mal. I work as a principal machine learning engineer at Nearmap. There, I lead a team called Data Engine who are responsible for model data, model training, model deployment, and continual improvement over this. I have a PhD from University of Sydney and I have a 13 plus years of IT industry experience working on various domains such as machine learning, data science, big data, travel, GIS, DevOps, and many more. I love mentoring and learning things. I also speak at technical conferences, particularly on topics such as machine learning, data science, or Kubernetes or distributed computing. I author for O'Reilly and I have also authored for IBM Redbook in past. Nearmap is the provider of high definition aerial imagery content. We have petabytes of aerial imagery already, and we are every day capturing terabytes of more and more content. With Nearmap AI, we are taking these visual contents and generating semantic knowledge on top of it. We are essentially building knowledge layers for various things and stuff in our livable world. Things like driveway, power pole, power lines, various types of vegetation, swimming pool, roof, solar panel. In fact, we already have 30 plus attributes already ready in production for customers' use, and we are rapidly growing that list as well. We take these semantic knowledge web and then we convert them into what we call location intelligence. And one such example of location intelligence is shown on the screen here. Here we are talking about the details of building, like what is the building footprint, what kind of material was used in this roof, like if it's tile, shingle, and what is the style of roof, hip, gable, etc. And likewise, if there are any tree overhangs, and if it is, then what is the size of overhang. We do this to simplify our end users and customers' product and workflows. So what underpins this sophisticated near-map AI product is a technology called deep learning, and I'm sure many of you would already be familiar with this concept. It's essentially a class of a supervised machine learning technique or a deep learning technique where we give a mathematical model a source image and also a ground truth. And when the model looks through the data, it learns the feature representation or a knowledge representation by looking at data. And once it has learned, then we are able to give any image to it, and it is able to predict with certain confidence to what attributes or things a pixel may be, things like swimming pool, roof, etc. Deep learning techniques are hungry for two things: data and also accelerated computing. But today, given we are talking about a data track and the focus being data, we will just talk about data and leave the acceleration piece out of it. So at Nearmap, we have various type of visual contents. We have ortho images, oblique images, and also various forms of 3D images like mesh and point cloud. These images help us visualize a certain location from many different views and allows us to really visualize a location or an object to a certain what it is, because sometimes when we are looking at from a different view, it's really hard to tell what we are looking at. And we leverage on these vast visual library that we have to generate a really good quality of a ground truth. So to leverage on that, we have an inbuilt or in-house built labeling system that our labelers use, wherein they can leverage on these various type of imaging modality and really visualize a location before they annotate it for various attributes or things and stuff. And I would like to also mention that we use well-trained staff, so they really understand the definitions of the attributes that we have in our system. So this is an empirical study that did analyze the impact of data on deep learning. And they found that as we increase the data or the training data set, the model starts to perform better and better. And it actually, the validation loss reduces sublinearly. What that tells us really is, as the bigger the training data is, the better the model would be. So sure, data size is important, but data size isn't the only solution, as the same study indicated that once you get out of this power law region where you can keep growing your data set and continually keep reducing your validation errors or generalization errors, then you come to converge into this irreducible error space that is really hard to close further in. So data matters and size matter, but what's more important is data quality. And it's quite intuitive if you look at it. The model is learning the knowledge representation by looking at the data itself. And if the ground truth is not correct, then we can expect the model to perform poorly. And this is very well represented by this little cartoon here. And when we talk about quality, we are not just talking about correctness, but we are also talking about variety, as it's shown by this little meme here. The only thing that's true in our world is imperfection. We as humans are imperfect, and also all models are wrong, only some are useful. And this is very interesting situation because we want our training data to be perfect data set, but all sources of generating it is quite imperfect. And I will give you examples to confirm that, I guess. Let's talk a little bit about the workflow that we observe on the data engine side at Nearmap. And what we are looking here is a very standard AI machine learning data workflow where we have a label capture program, then a ETL pipeline, then a model training program, and then model deployment. But at Nearmap, we have come to evolve this workflow quite extensively, and I'll take you through that. One adaptation is adding the review or correction workflow where jobs are reviewed by another labeler to make sure the quality is correct or acceptable. And then as our models are out in the wild, they are doing inferences, we do a monitoring where we look at the locations where our models are uncertain about, and we pull that back into our data set. And then we perform what we call adaptive sampling. And this is a mechanism to pull in locations and images where our models are not confident and feed that back to labeler to generate ground truth, and then back to model training to get our models to continually perform better and better on the things where it hasn't been very confident in past. And then we also utilize our model into labeling system where we pre-populate the labeler's job with the model's prediction, and then we allow labelers to correct it instead of painting on an empty canvas. We do this with the hope that this will help them have a better labeling experience and also do an efficient labeling. In fact, we also did a survey with our labelers, and the results indicated that our labeler thought that pre-population helped them perform labeling much more efficiently and accurately with pre-population. And then we also utilize model in quality check programs to identify where the ground truth data may be incorrect. And I will lead you with various examples to help you understand why we have adopted these approaches. So first is mistakes are real, mistakes happen, they happen just because we are human. This is one such example where labeler was to annotate roof, and he missed that particular highlighted roof but labeled everything else correctly. And then sometimes we make mistake because objects are really hard to perceive, or there is cognitive issues in identifying objects in this example where you can see that particular car is really hard to spot, and this labeler missed annotating it. And then we also see some really strange cases in the real world that is really hard to explain. Like in this example where a trampoline is actually kept in a empty swimming pool in a family's backyard. And if we don't see these visual examples, it's really hard to imagine these scenarios being real. But there we have it in real time. Another approach that we adopt is majority, where we give the same job to many labelers and take the majority opinion as the final ground truth. And in this example, the labeler annotating for driveway actually annotated the entire drivable surface, including the parking spot, which is not quite correct. But when we took majority, we actually had the right definition of driveway there. This is obviously quite expensive operation because the same job is being done by many labelers at the same time. Okay, so let's talk about how we are using model in quality check. Here, there's a job that was given to a labeler to annotate natural soft, meaning dirt, and grass. And this is the label returned by the labeler. And as you can see, the labeler completely missed annotating grass and actually only annotated dirt. But even for dirt, the annotations are not quite correct. There are patches of dirt that's not correctly labeled. You can see little bits of dirt shown not annotated. Now we do understand it is quite hard class to annotate. It's quite ill-defined and wiggly, but not having the correct representation or correct ground truth is not going to help us with a good model. So it's really important that we identify these issues. And another example that was picked by using model in the loop for quality check is this, where a particular labeler missed annotating water in the entire image completely. This is another interesting case where we use model in the loop for quality check. And here we are looking to identify errors in the label due to noises in the image. Noise could be related to the capture condition, like maybe there is a cloud, maybe the image is grainy, or possibly the lighting conditions are not quite correct, or maybe there is occlusion, shadow, or many such reasons. And to identify issues coming from this, what we do is we look at predictions over many images captured at a different point in time and find an averaged prediction for for the objects we are interested in, and we compare it against the labeler's truth. And here, as you are seeing, we are identifying this particular job being poor because the labeler has missed annotating the middle swimming pool. And then the example of using model in the loop for annotation. So this is a good example of both human and model in the loop. The job is being pre-populated with model's opinion of what the label should be, and then we use labelers to correct model's prediction. And the purpose here is two-phased. We are not just looking at helping labelers do efficient labeling, but also identifying where the difference is in the opinion between the model and also the labelers. And this data could be very useful for us to understand where our models are doing poorly. And then all these various ways of quality check and data quality and data management is important. But what's also important is continually updating the definition of attributes that are already strong. And this is important because our definitions of things and stuff continually change as we go in progress in time. And this is a good example here where the definition of car as envisioned in the 80s has drastically changed to how we envision car currently. And if we don't continually keep updating our data set, then we run the risk of concept drift or data drift, where our data or the model's understanding of what the feature is drifts away from the reality. And for this reason, we also continually keep updating our data set with the strong classes as well. That was all about data. Now there's a lot goes on the data engine side. There's a lot on machine learning side, then model management, model monitoring, and also what happens with attributes and their relationship between them. This brings us to Techstack. This is our bird eye view of technology stack, and as you can see, at the heart is AWS, which is our choice of cloud provider. We quite heavily use EC2 and S3 along with other AWS services as well. In fact, we are one of the biggest users of S3 in Asia Pacific. We prefer Kubernetes as our choice of container orchestration platform, and most of our workload are containerized. On the data side, we look at Snowflakes and Looker for analytics and reporting things. We use Kafka as a messaging and backbone, and we use TensorFlow as our deep learning SDK, and then Python, Golang, and C++ as our language stack. We have actively talked about how we utilize AWS and AWS services in our workflow and how we run our applications at scale, both in terms of compute and also data. And while we do that, how we keep our cost minimal by making use of spot instances and various other tweaks. And I would like to point your attention to these links that talk a little bit more in detail around those things. And with that, I would like to take a minute of yours to talk about hiring. We are looking for software and data enthusiasts to come and join our team and help take Nearmap AI to the next level. So if what we talked about today and what we are doing with AI, deep learning, or engineering, if this seem of interest to you and you would like to find out more, please feel free to reach out to me. My details are mentioned there. I'm also available on LinkedIn and other social networking channels. And also, if this is not the right time for you, if you are not looking for opportunities and you would just like to reach out, have a chat, or maybe exchange notes, please feel free to reach out. I'll be very happy to have a chat. And with that, I would like to take questions if there are any. Thank you.
Cool. Welcome back, everyone, and thank you, Sunita, for such an interesting talk. We've now got Sunita live, so we're going to hit her with some tough questions that we can see in the Twitch stream. So maybe we'll kick off with our first one from Ren Gary, with how much training is required to get the optimum annotation?
Cool. First of all, thank you for having me. Really excited and thankful to be here. It's a really interesting question when we ask about how much training data is required to get good annotation, because it's not just the size, like as I talked in the presentation as well, we can't really put just a number on the size and say, if I have, say, 2 terabytes of data, that's enough to get good annotation. It's also about the quality of the data, how varied it is, and how much it generalizes and helps the model to learn. So assuming that all that is um, taken care of and your data is really diverse, good quality, and has fair size, then it also depends on what kind of ML model you are using. There is no one answer. It's the same thing in every world. There is no answer that fits. I think it's not a black and white thing. So depending on what algorithm you use, the answer would vary. Like traditional machine learning, you don't really need a really large data set. Few hundreds to thousand is probably enough to converge because we're talking about specific features. But if you start to talk about deep learning, which is like quite data hungry, we generally talk in terms of at least gigabytes, in tens or hundreds of gigabytes, or ideally in terabytes. Or if you're feeling really rich, you can talk more in those context. But there's actually the study that I've cited in my presentation. It's actually really good practical study that talks about how can you converge onto the right data size given many factors, like how much can you afford to pay to get a good data size, and what is your source, and then how your model is converging also on your data set.
Yeah, I love how in the data world it depends. That's my favorite thing. Cool. I have a question. How do you find a good balance between all those quality check methods?
Yeah, it's a very good question, and specifically because when we start to talk about quality, there really essentially we're talking about two kind of approaches for quality. One is taking human annotations and giving it back to the human to do the quality check, and to strike a balance, it really comes to about the cost in terms of time and how much money you are ready to spend to do all these quality checks. If you really don't, like, if you're really not limited by the money, then I guess 100% coverage is always the good thing to do, but it's really not so practical. But when you start talk about the other side, when you have the model in the mix and you're really trying to understand the impact of both human and model in the loop and how they are interplaying, then it starts to become um, it's something that you need to get a feel of, throwing in your model and seeing how it's behaving on different classes, different attributes. Uh, the good rule of thumb is some classes, like, they are really easy to train on, like roof. It's really straightforward. Like, roofs are generally squarish. There is only little variations to it. They are very sharp on the edges. But when you start talking about grass, they are very fuzzy, very unpredictable. Uh, like, low vegetation, like low grass, it's really hard to find how you would rely on model, like who is correct, human is correct or the model is correct. And also the other factor is, when you start training and you have a really small data set, your model would not be very strong on those classes. So finding that right balance between what is the strong class, what is the weak class, and what the thresholds for these classes would be. And that's something that would come through experimenting and seeing and feeling a lot of your data, like just sitting through, seeing what it works, and also like running through a lot of batch operations on your data set to just get a sense of what threshold works for you, what threshold doesn't work for you. And then also treating this as a more advice than a quality check, because a model, like, they are only suggesting.
Yeah.
And you really need to bring in human back in the loop to confirm that what model found is actually the right thing. So uh, I'm not answering this straight away because it's something really hard to achieve in practice, but this is basically how we are doing it, to get a sense of what those numbers look like for individual classes, depending on how strong and weak they are for us, and then also putting in human to just confirm that what we have found is actually correct. And over a period of time, you start to get on top of it because you have seen so much on it. I guess that's how data works, isn't it?
Yeah. Yeah, that's how you find trampolines in swimming pools, right? That's my favorite thing from that talk. Did you have a question, Peter?
Yeah, I think, we were having a joke before about Rengary's comment around spy mode activated. This whole mapping thing, it's got a bit of a James Bond feel to it. But Sunita, can you take us through a couple of government use cases for the data products that Nearmap offer?
Yeah, sure. So a lot of use cases of our images are around urban planning. Like, there's a big construction like Norwest Metro planning. So where should be the stations installed? What should be the road pathways and how should the station look like and things like that. Also, the new areas where we are starting to build up new communities. Like earlier, it used to be just vegetation or, like bushes. How can we restructure them to build a community, and what should be the placement of schools, and all the things that a government needs to think through to plan a good community and good livable area and livable space, I guess. Those A lot of our imageries gets used in those contexts. That's the one very common use case. Some other use cases are in koala habitations. We, like, with all these constructions happening, our uh, wildlife gets replaced, like, excuse me, not replaced, but they get impacted. We are encroaching, like we humans are encroaching every animals and their territory. So how can we rehabilitate themselves to find a newer space where they can grow and develop, I guess, find the wild again. That's another use case. There are actually quite a lot of use cases as well, like 5G installation is another use case. What's the best location where we could install 5Gs?
Mm.
Oh, fascinating. And I guess there's a couple more questions coming through about model drift and the like. I mean, I don't know if you've got a few quick little comments on those topics.
Yes, so there are quite a few algorithms that's available to use and identify model drift. They are quite easier to work with if you are working with traditional machine learning techniques where you have feature and you can actually do online training as well. So then you can keep all the data that's coming in. You can treat that as an online training as well and see um, how the model is diverging from what you had previously to what the new one is new output is coming through. But it's quite hard with deep learning or specifically convolution networks because there is no online learning concept because of back propagation. So there are actually a few approaches, but they are still actively under research, and there is no straightforward way to do that. So the way we are working through concept drift is semi offline. I think that's how I would put it. And really, the way to look at it is data drift more than a concept drift, because the training then is an offline process because it being a convolution. But if you are into classical machine learning, then there are quite a few literatures on how you can use online learning to really build on identifying concept or data drifts.
Awesome stuff. Well, I think we're at time, so thank you so much, Sunita. Fascinating talk. I think Nearmap are doing some incredible work. The scale is just mind-boggling, and so it's always really great to hear from folks that are pushing the bounds of not just in the data field, but also in the machine learning field as well, and seeing, I guess, the confluence of the two. So thanks again for sharing your insights with us today. Really appreciate it.
Thank you very much. Good luck with the rest of the sessions.
Awesome.
Thank you.
Gonna cut.
Welcome back, everyone. We have our next speaker, Terence White, who has recorded a video on his project on New Zealand base maps. So Terence works for Land Information New Zealand, or LINZ, if you're familiar, and he joined as a senior AWS engineer about 1.5 years ago, and has been busy working on setting up a cloud landing zone and the network connectivity backend for the New Zealand data centres. Terence's talk is going to show us how LINZ takes terabytes of raw aerial images and processes them using AWS services to generate maps at a fraction of the cost of doing it the traditional way. Terence is going to be available in the chat, so please ask your questions and we'll roll the video now.
Kia ora, fellow AWS enthusiasts. Welcome to this AWS Community Day presentation. A big thanks to AWS heroes who have put this on and have allowed me to talk to you today. My name is Terence White, and I'm the Enterprise Platforms Manager at Land Information New Zealand. This means I look after the people who look after the cloud platforms our exciting projects are deploying onto. I've been using AWS for over 4 years and have 8 of the AWS certifications under my belt. Today I'm going to tell you about one of the projects that we've recently released onto our AWS platform that I'm particularly proud of, the New Zealand base maps. But first, just a little bit about what Land Information New Zealand, or LINZ as we're known, does. We're the government department that's in charge of the register of who owns what bit of land in New Zealand, and we manage the reference points for the boundaries of the land. We produce maps and charts, we look after government-owned land, and we support the government ministers who need to make decisions about foreign purchases of major New Zealand assets. So what are New Zealand base maps? Well, territorial authorities like the district councils around New Zealand pay contractors to fly aeroplanes over their districts and take photos with a high-resolution camera pointing downwards. They use these photos for district planning and other nefarious purposes. When they're finished with them, they can give us a copy of these photos, since they're digital, and we put them into our data lake in AWS S3, alongside the photos from other councils. So the base maps project is taking these photos and turning them into high-resolution map background tiles. And where we don't have enough photos, or we have a gap in coverage, we're supplementing the data using less detailed photos from satellites. We're making these map tiles available online for free to anyone who wants to browse New Zealand using a web front end similar to Google Maps, Satellite View, and to developers who want to put their own product together, like a mobile app or a GIS product that needs a detailed map background of New Zealand. We've released our product with aerial imagery, but we have other base maps with topographic features like roads, building outlines, and street numbers on our roadmap. No pun there. We're also publishing the source code for the project on GitHub for anyone to use for their own education or mapping project, and our devs are happy to engage with other developers around this product. Here's a couple of examples from the web app. On the left, I've focused on to my house. And from the shadows, I'd guess the original photo was taken around noon, and it looks like I had a visitor over. On the right, I started zooming into Auckland, and I found something probably a bit more familiar to the audience, Eden Park Sports Ground. So you may already have guessed that we're dealing with pretty large amounts of pretty big photos. And TIFF files might be great for long-term archival storage, but the point of this project is to return map tiles whose coordinates won't align to the TIFF files directly to users as quickly as possible. So we can take as much time to prepare the data as we need, but once the map tiles are live, we aim to return 99% of tile requests within 900 milliseconds. And we know users will be requesting tens to hundreds of tiles in parallel each. To make it easier for the output tile process, we use the Geospatial Data Abstraction Library, or GDAL, to combine TIFF files into larger images, and then compress these larger images using the WebP lossy image compression format developed by Google with a 90% quality setting. Now, this reduces the currently 17 terabytes of data in our data lake down to under 1 terabyte in the base map's image cache. We also use GDAL to extract some metadata from the TIFF files, as we want to make sure that we correctly attribute the source or sources of the output tiles, and we need to know the location of the photos for producing tiles later. This metadata is stored in an Amazon DynamoDB table, so we can meet the scalability needs of the service. We're talking to regional authorities about bringing historical data sets in, which will allow users to compare a particular area over time, but which will also increase our input data tremendously. So on the left here is a diagram of the image import process, which might help you visualize it a bit better. The images are only imported into our system after they've passed a basic QA sanity check by our staff. The red squares show the larger cache images that we produce from the multiple TIFFs. We run GDAL inside a Docker container and use AWS Batch to run many containers at once on Amazon Elastic Container Service, or ECS, on EC2 instances. We use Python scripts to orchestrate the process and to schedule the processing jobs inside AWS Batch. The EC2 instances are spun up to run the containers, which do the processing, which is actually fairly simple, and then terminated to save costs when there's no more work for them to do. In the picture on the right, we have an overlay of the files we've received for the Wellington City urban region, just to give you an idea of how many TIFF files we receive at once, and the scale of the processing that we need to do for each distinct data set. Since we don't generally need the processing to happen super urgently, we tell AWS Batch to use Spot instances. For those who don't know AWS Spot, it allows you to run workloads on AWS when there is spare capacity, like at weekends or in the evenings, at a fraction of the price of on-demand. We set a fairly low spot price threshold, which allows us to make quite a bit of savings. The processing is primarily compute-driven rather than memory or I/O, so we use the C5 family, and we'll be looking to see if we can move to the C6G family if all the software we use is compatible with the new AWS Graviton ARM processors. We're running many Docker containers at a time on the instances, so we use the 9x large instance type, which gives us 36 vCPUs and 72 gigs of RAM. And it makes calculations for the batch scripts which orchestrate the processes easier. Up on the screen, we've got an example of where we did some processing, and the total cost was under $50 for 70 of these large virtual machines, which ran for just about an hour each. If we had to purchase a similarly spec'd server to give us the same amount of processing power in our own data center, there's no way it would cost any less than 1,000 times that. And we still have all the other costs of feeding and watering the server as well to account for. Right, so now we've got a whole lot of processed images in the cache in S3. The question comes down to how do we serve them as map tiles, and how do we serve this to the potentially millions of users requesting potentially hundreds of tiles at a time, and do it quickly enough at scale that they don't have a bad user experience, give up, and move away to another product. And once again, AWS comes to the rescue. I'll walk you through the process of a single user requesting a single tile. The process of requesting the many tiles needed to fill a desktop screen in a web browser is exactly the same, but done in parallel to maximize the network bandwidth. So the tile request will go to an Amazon CloudFront distribution. CloudFront is Amazon's content delivery network, or CDN, and provides a caching layer at many more locations around the world than AWS has regions. A big shout out to AWS for recently bringing CloudFront to New Zealand. That's reduced our network latency by more than half. There's a Lambda at Edge running in CloudFront, which checks the user's API key, if they've passed one through, against the DynamoDB table so we can keep track of who's using our system. If CloudFront has the tile in the cache, it'll return it to the user directly. If the user is requesting a tile not in the cache, then CloudFront connects through the congestion-free, high-speed dedicated Amazon network to the tile Lambda sitting in our AWS account in the Sydney region. In theory, this will check to see if we have already cached the tile in an S3 bucket and return it if we do. If we don't, then the tile Lambda will create the tile by combining parts of images as needed from the processed image cache and the metadata database we created earlier, and store it in an S3 bucket tile cache for future use, and then return it. In practice, we've found that the creation of the tile is so quick that we don't need to cache it in S3. We haven't implemented the intermediate delivery cache yet. We'll keep that in our back pocket as a future performance enhancement if we need it later. By using AWS Lambda function as a service, this solution will effectively scale itself up and down to meet demand. No intervention on our side. We also don't have any servers that we need to maintain. Does it work well? I think it does. As you can see from this graph, we were serving well under 100,000 tiles an hour on a Friday evening in early September. And then we got featured in an article on NewsHub, one of New Zealand's widely viewed news websites, which later resulted in someone posting a "Hello fellow Redditors, look at this cool thing" link in the /r/New Zealand subreddit. Both of these actions caused immense spikes in traffic to our site. We served over 350 times the usual amount of tiles per hour in the 2 peaks, with a total of well over 50 million tiles over the 2 days of the weekend. The CloudFront cache was able to return 60% of the tile requests directly, and of the remaining 40% that were generated, we were able to return 95% of them within 300 milliseconds, which well exceeds our SLA. The tile generation Lambda was able to scale up to meet the demand automatically and then scale back down again as demand tailed off. No users reported problems with tile delivery. Our admins didn't even know about this until they got in on Monday after the weekend, checked the logs, and then had to go and do some digging to find out what had happened. I'll switch over quickly and give you a live demonstration of the product. So this is the Basemaps front-end website, and I can move it around, and it's pulling those ocean tiles from our server, and I can zoom it in. I'm going to roll the mouse wheel over the Wellington region here, and as you can see, it's pretty quick, pretty seamless, and it's pulling those tiles in from our CloudFront cache on demand. Oh, I see something I recognize in Wellington. Sports stadium. And if I zoom right in, doesn't look like there's a sports match going on there. I think they're preparing for a concert or something like that. Right, so this is a tribute to all those maps out in the world that don't feature New Zealand. We, in fact, have a map that only features New Zealand. If you zoom out far enough on the product, you'll see that we do have a lot of the ocean details, but all the other continents and places are blank. Well, thank you very much for allowing me to present on the technology running on AWS behind the New Zealand Basemaps product to you. I hope you found it both educational and interesting. If you want to find out more about the product itself, you can go to the top URL. And if you want to try the web app front end, have a bit of a play around like I did, head to basemaps.linz.govt.nz. All source code for the product is available to the public in the GitHub repository linz/basemaps. We're using the AWS CDK, so there might be some interesting things in there. To get an API key that you can use in your own development projects, or to get any further information about the product from the support team, please send an email to basemaps@linz.govt.nz. For Land Information New Zealand, I'm Terence White, and I'll now be answering any questions you might have about this.
Welcome back, everyone, and thank you, Terence, for a really interesting talk. Always really cool to hear how the Kiwis are doing it. So yeah, I was particularly interested in this talk. We now have Terence here with us, who's going to answer some questions from the Twitch chat. So welcome, Terence.
Thanks very much, AWS Heroes.
Cool.
Do we have any questions?
Yeah, I have a question to kick us off. Yeah, I'm really curious about the use cases you've seen for the web app. Have you seen anything been interesting that's been done with that?
Well, at the moment, it's still quite new, and the first thing anybody does when they get this is really go zoom in on their own house and take a little bit of look around their own shopping malls and things like that, see if they can recognize some of the stuff that they do on a day-to-day basis. But we're going to be integrating this product into a lot of our other products that we've got. So we don't just do this, we have other things, and they use maps. And if they need a high quality New Zealand map, then we want to try and push this into a bit of eating our own dog food. It's an organization that does a lot with this sort of stuff. We're also going to speak to the other departments inside New Zealand government and do a bit of a drive over there, see if we can get some of our brothers coming and using our stuff, and that'll really open up the exposure and give us quite a bit of exposure there.
Nice. Yeah, that's really cool. We do have a question from the chat. Stews NZ says, "Hi Terence, in reference to the API keys on offer, are there specific limits you can take us through or costs to create something using Basemaps?"
Sure, the cost is quite easy. This is free, and the keys are set out for a 90-day period, and then we'll give you a renewal on the 90 days. That's just really so that we can see who's using the product. So when you apply for the key, we'll record that you get this key. And then later on, when we analyze the data, we can say, well, the volume of business you're driving is so much. And it's just to help us keep track of it. We're not charging for any of it at all.
Nice. Stu also says, "Congrats on the great rollout," and he remembers looking at it when it got released. So that's nice.
It's probably his fault that we had those spikes. But thanks, that's what we want, right?
For sure. Always good to know when someone's using your product.
Yeah.
Yeah. Speaking of those spikes, you mentioned that it was some publicity last time you saw a spike. Have you seen any more spikes since?
No, we've really had the two. I think if something comes out of this talk, we'll probably notice it, and I'll ask our devs to have a look on it. But it's really when it hit Reddit and the news websites and things, and people jumped in to go and have a look at this all at the same time, obviously. And that's where we saw those spikes coming out there. Nothing subsequent to that, but it's not to say that somebody won't post the links somewhere else, and then we'll wake up one morning and find that it's jumped again.
Yeah, everyone's going to check out what their house looks like.
Yeah.
Love it. Any questions from you, Peter?
Yeah, I'm really keen to hear, Terence, what sort of tech are you using to capture all of this? Drones, planes, any sort of things on the roadmap for the future?
Well, at the moment, we're just getting the data for this from the various councils around, and they just have airplanes flying over. Everyone's always worried about those spy cams and things up in the sky, and we're using the normal satellite stuff. But sometime in the future, our organization is looking to do a map of New Zealand by having a company or many companies flying over it using drones with LiDAR on it. So we'll get a LiDAR map and probably make it available through this service as well as whatever other original service that they were planning to use that for. I just can't even begin to think about the size of the data that's going to come out of LiDAR scans of the entire country. So we're looking at really big volumes there.
Yeah, cool. And I guess, a lot of the elasticity that we find on AWS is, is probably helping a great deal in just being able to handle that. So that's really cool. The maps, we've got a question from Andre 2020. Can you use it for road network routing? Have you got road centerline data available in there as well? Or
Not at the moment. So this one is just aerial photographs. But on our roadmap, right, we've got the bringing in of actual topographic features like roads. I don't know if we'll bring the center line in, but definitely bring in some of the roads and other things as well, like houses and street numbers and stuff like that. It's all on the list of things to get around to.
Yeah, nice. And I guess what's the differential? Just a random question from me that popped in my head between this and say Google Maps, for instance.
It's the currency of the data at the moment. So I think Google Maps will send the satellites over every couple of years, and we're not doing everything via satellite. We're doing it with the town councils who do things on a more frequent basis because they need it for the town planning. Or if, God forbid, one of the natural disasters that hits New Zealand hits, they send over planes and other things to get the photographs of what happened, and then we can bring those images into the system a lot quicker and make it available a lot quicker than what Google Maps can do, or any other product based on just satellite images.
Mm-hmm.
Just lastly, sort of what's your average time delay between sort of capturing maps and or what's the recency of the data there on the website?
If you go and have a look on the website, there'll be a tiny little bit of text at the bottom right corner, I think, that's got the source of the data and the date or the year of that. So we got stuff from 2017, 18, and 19, and there's possibly some 2020 stuff in there. I mean, I haven't gone around and taken a look in detail, but it is all attributed, so you can see what the currency of the data you're looking at is over there. And when you talk to the people about the API keys, they can show you the API and show you how to get that attribution data, the source data's details, through the API so that you know how fresh that data is.
Oh, wonderful. That's cool. Any other questions, Helen?
Yeah, you mentioned the new CloudFront, well, recent-ish CloudFront location in Auckland.
Yeah, so happy.
Yeah. Do you see an availability zone or a region in our future?
If I was to roll the bones and make a prediction, I'd say maybe a local zone. I wouldn't go as far as saying a region. I think for a region, you'd need to have some geographically diverse data centers and they'll need power sources and stuff like that. It might be just a step too far, but I'm certainly holding out for some announcements to come out,
Yeah.
hopefully at the reInvent around local zones.
Yeah, that'd be really cool. All right.
Nice.
Any other questions, Peter?
No, I think that's really cool. I'm sure you're going to hang around for a little bit, Terence, to answer some of the questions in the chat.
Yep.
On Twitch. As always, it's great to hear all of the fantastic work that's happening over the ditch. I'm Sydney based myself, so and just hearing all of the great innovation that's happening. So right around the region. So thanks so much. I think we've just had two really cool mapping presentations in a row, which is it's just great to see what sort of innovations happening on AWS at the moment, especially in the data space. So thanks once again, Terence.
Thanks very much for letting me present, people.
So we're just going to break for a little bit and we'll be back shortly. Chat to you shortly. Bye. All right, welcome back. How's it been so far, Helen? What do you think of the talk so far?
I've been loving it. I'm a big geography nerd, so this has been right up my street. And yeah, hearing from a Kiwi speaker has been really awesome.
Yeah, it's great. I think we've, without sort of putting tickets on ourselves, I think we've done a really good job of, putting together a selection of speakers from right around both countries, showcasing that, all the great innovation that's been happening, especially in the data space on AWS. So it's wonderful to hear all of these great use cases. I'm super proud of all of the great stuff that's been going on.
Yeah, I love mapping technology and how far it's come. When I was a little bit younger, I was wandering around London with my giant tourist map, looking really conspicuous. So it's come such a long way with Google Maps and other cool products, say from Lens and Near Maps. Really cool to see.
Yeah, I guess it was a lot easier to spot a tourist back then, wasn't it?
Yeah, I'm not quite so slick with my mobile phone.
Yes, absolutely. No, it's great. I guess we're going to be changing tracks pretty soon, though. We're going to sort of start getting into a bit of serverless data engineering, aren't we?
Yeah, right up your street, right?
Well, I could be accused of being a bit of a serverless data engineering fanboy. Yeah, I guess so.
We'll let you have it.
Yeah.
You've done a good job so far, so you can stay.
Awesome. So tell us about who's up next, Ellen.
Sure. So up next we have Jeremy Nagel, who's going to be talking us through Lambda versus Glue, serverless ETL and ML. Jeremy has a background in environmental science and focuses his career on building tech that can help avert climate change, very hot topic right now. He works for two startups, GoFar, which is a vehicle fuel efficiency company, and Okra Solar, a solar microgrid company operating in Cambodia.
Cool. So Jeremy's talk will discuss how GoFar uses Lambda to ingest data, run machine learning jobs, and compact Parquet files for their Athena-backed data warehouse. Without further ado, take it away, producer John.
Hey, Jeremy Nagel here, talking to you today about Lambda versus Glue, my experience with using serverless ETL and machine learning. What I'm going to cover today is a couple of case studies about using Lambda for ETL and machine learning, and an explanation of why my colleague and I went down that route at GoFar. Before I get into it, I should say that I'm not an expert at PySpark, and so any aspersions I cast towards Glue are probably based on my own lack of skill there and my level of comfort with Lambda instead. So if you do great things with PySpark already, please keep doing them. This is more for people like me who I'm not really a proper data engineer. I'm just cobbling things together, and I've mostly got them working, sharing them in the interests of other people who might be interested in playing around with Lambda and seeing what is possible to do with it. To give you some context on what I was trying to achieve, I work for a company called GoFar that does mileage tracking for drivers. That might be an Uber driver or someone who's a courier. They're driving around all day, and because they're using their own vehicle for business purposes, they're allowed to claim that back in their tax return. They need to have some data on what trips were business related and which ones were for personal use. Now, I'm mentioning that because that's one of the use cases later on, that part of what I was trying to achieve was using machine learning to automatically categorize trips as either being business related or non-business related. But let's begin with the very first high-level overview of one of the ETL jobs that we had. For a long time, GoFar was coping with data ingestion in a relatively naive way, where we were ingesting data in real time using a Node.js API and directly dumping that into our database. That worked well for a couple of years, but we reached a scale, not super big data scale. We've only got 2 terabytes of data in the database, but even at that point, we were starting to see issues where by doing all of these ingests at the same time, we were really causing our database server to struggle a bit, and it was also compromising the performance of the backend API. For that reason, we wanted to move to a model where we would put the telematics data, as we collect data every 2 seconds from people's phones while they're driving around, and that data, instead of immediately ingesting it, instead we put it onto a queue, which means that in peak hour, when there's a lot of telematics data being uploaded, we're not trying to do it all at once. Instead, we can gradually fill it in as our servers have capacity later in the day. And what we wanted to do, as well as putting it into the database, was have a transformation layer where we could do some aggregate statistics. We could look at, were people driving safely during that trip? We've got data from a accelerometer that's plugged into the car's diagnostics port, which means we're able to know where they're really putting the brakes on hard. And based on that, we can identify trouble spots, and we can also help the drivers to understand whether they're getting better at driving in a smooth manner over time. We wanted to be able to calculate those trip level statistics based on the raw data, which meant that we needed a transformation layer. We weren't really sure how to handle that. We could have just done it in the normal Node.js backend API, but I mentioned that we were already starting to see problems with that. We didn't want our request times to become even longer. Instead, we wanted to have a separate ETL layer and probably not use Node.js, probably use Python instead, because it seems a bit better suited to these not super duper data sciencey, but moderate level data analysis tasks, which meant that we had to think about how we would run that Python code. Would we use Spark? That's one option. Would we have an EC2 instance, or a fleet of auto-scaling EC2 instances? Would we use ECS and run Docker, or use Kubernetes? Or would we have a crack at using Lambda? And in the end, I personally find Lambda really nice to work with as a developer. It means I don't have to think about infrastructure as much, and so I tend to default to Lambda, and only when I discover that something's impossible in Lambda will I resort to the heavier duty ways of being able to run code. In this situation, for what Gofire is doing, we've been able to do all of the ETL steps via Lambda and also some machine learning. So I'll start out with a bit more detail here about pros and cons of the different approaches that Glue is designed via PySpark for ETL and a little bit for machine learning as well. It's meant for operating at scale. The con is that I've only used it a little bit, but I found it impossible to understand. I got it. It's a combination of me not knowing PySpark very well, and also that AWS has admitted to me that the errors that you get out of Glue when you're running it are pretty incomprehensible, hard to use, whereas if you're running Lambda or a ECS task, it's pretty easy because you can get standard application exceptions out of that. With Lambda, the biggest pro is that it's super easy to develop and deploy. The con is that if you're wanting to do an analysis task that takes more than 15 minutes, then you're out of luck there. And then with ECS, you don't have to worry about timeouts, but the con is that it's not really a cool technology choice. It's a bit boring. So I wanted to stretch the limits a little bit. Start out with one of the easier things to do, which is the ETL step, where we're wanting to transform the telematics data and do some aggregate level analysis of it. For that, I'm using AWS Cloud Development Kit, CDK, to define the infrastructure. You can see here that setting up a Lambda function, passing in a secret, which has all the database passwords and other secrets we might need, as well as a queue, SQS queue URL that it will pull data from, and also we're pushing data to a third-party service, Compass IoT. That's another SQS queue there, and then granting permissions down the bottom. Here's the Lambda handler. You can see at the top I'm trying to do something around having an RDS connection pool. We're using Postgres 12, which means that we, at the time of recording, RDS proxies aren't available, but I'm really eager for that when it comes. And then the code is pretty simple, and I'd argue for me pretty easy to understand, that we grab some data out of SQS based on, because this function is triggered by SQS events. Basically, the backend API will push a SQS message when it receives a batch of telematics data, and then this Lambda function will process 10 of those messages at once. Then we pull our database username and password out of AWS Secrets Manager, generate a database client, and then we push the data to our Postgres database, and we also upload it into S3 in Parquet format. There's a bit of detail to both of those steps, but relatively elementary code around using Circo PG2 to push the data to the database, and using a Parquet formatter in TypeScript to upload the data to S3. The next challenge that we had was we were pushing data in Parquet format to S3, but the problem was that our files were very small. The documentation for Athena recommends that you make your Parquet files around about 128 meg. Initially, I was pushing them at around 4 KB. I then batched it up so that there were 10 of them at once, and then it was more like 18 KB, which is still way too small. For that reason, we wanted a way that would merge these Parquet files together. I couldn't really find a nice, easy way to do that. There's meant to be a way of achieving it via glue. I couldn't get that to work. And then there were a bunch of blog posts that didn't really do it in the right way, because in order to really actually improve the query time, you can't do the naive way, which is to basically concatenate the Parquet files on top of each other. The reason why that doesn't work is then you have header files, or the header row, repeating every, 100 records or so, which means that for Athena it doesn't really speed it up. So instead, what I did is set up a Lambda function that used PyArrow to, well, first it loads the Parquet data into a pandas data frame, and then it concatenates all of the pandas data frames together, and then finally it uses PyArrow to generate a merged Parquet file. You can see here that after the first pass, it converts those 15 KB files into about 2.7 meg, which is an improvement, but not quite good enough. The third step is that it then merges those 2.7 meg files into a bigger file. You can see here that for this hourly partition, there was 17.8 megs worth of Parquet. And that's all of the data for that hourly partition. It's not quite 128 meg, but that's all of the data. And Athena is smart enough that the way that we've set it up, we've got a key with hour equals 12 or hour equals 13. It will only scan within that path, which means that it's only going to be looking at one Parquet file. 17.8 meg is therefore pretty good. So the code for that, I don't seem to have it there, but it's basically as I described it. It uses AWS the AWS S3 SDK to download files from S3 based on a path prefix, and that prefix is based on the partitions where we would have the hour and a date string, basically an ISO 8601 date string. And then we look at all of the files that are in that particular partition. We're able to then download. The reason why I did it in 3 stages is because I was concerned about the Lambda function timing out. So instead, we process about 5,000 of these files, and that takes around about 10 minutes. And then after it's done with that, it pushes the file into a processed subdirectory, even though it's not really a directory in S3, that essentially the file key contains processed. And then finally, stage 3 is that if there are no files in the raw data subdirectory, it will then look in the process subdirectory, and it will do the same thing of reading all of the files into a pandas data frame and then spitting them out again into a merged file in here. The thing that was slightly complicated about this is that PyArrow is quite large. I think behind the scenes, maybe it uses a Java binary, which means that the size of the code in total is more than 250 meg. That limits what you can do with Lambda. With Lambda, there's a problem where you have 500 meg worth of storage in your temp directory, but your Lambda function zip file cannot be more than 250 meg. I've tried various options around using Lambda layers. Same issue there. Even if you try and put the PyArrow dependencies into a Lambda layer, the total size of all of your Lambda layers and your function code cannot exceed 250 meg. For that reason, we have to use what's called a slim handler. This is borrowed from the Zapper framework, which is a kind of like the serverless framework, a way of pulling in, or a way of building your Lambda functions and deploying them. What it does is it creates a slim handler, the opposite of this little dog here, where the slim handler just has one job, which is to download the main Lambda binary from S3. It downloads that from S3, puts it in the temp directory, changes to that directory, and then wazam, you've got your Lambda code and also PyArrow and any other dependencies that you want there. That allows you to get around the 500 meg limit. The other way to achieve this is to use EFS. When I was writing this code, EFS support for Lambda didn't exist, and you can now do it that way. I still am happy with my S3 solution because it generally works. If you were running a more inconsistent or irregular job where it only ran once an hour and you were very conscious of cold starts, then you probably would want to prefer an EFS option. But for me, because these functions are running hot, they're running basically at the concurrency limit. I think I've got it set to a concurrency limit of about 5, which means that at any given point, there's always 5 running, basically. Okay, here's the CDK code for it. The fat lambda is stored in a S3 asset. That gets turned into an archive, a tar file, and then that S3 asset, the key for that, is passed in here as an environment variable, which means that the slim handler knows where to find it. The other thing, even though I didn't use EFS to store my dependencies, I did use it as a bit of a hacky state management system, because I needed to be careful with concurrency that I didn't want multiple Lambda functions trying to download the same S3 files. For that reason, I set up an EFS system where definitely the wrong way to do it, but I couldn't be bothered spinning up DynamoDB. So I'm just touching files in order to indicate which S3 directories are currently being processed. And then after it has finished being processed, it deletes that. Well, it's not a file, it's a directory. That worked pretty well, but I did experience a bit of a bill shock because I'd copied the EFS code off the AWS blog, and they had set it up by default with the code had provisioned concurrency or provisioned throughput for EFS. You can see up here at 1 gigabit per second, which is quite pricey. I think I ended up spending about $800 on EFS throughput in the space of 3 days before I realized. And the S3 API requests were also quite massive too, because I wasn't quite doing that in an optimal way. So you want to be careful with these things. Keep an eye out on the billing. I had an issue with our billing alerts where they weren't coming through, and I missed it for a couple of days. But thankfully, AWS were nice and acknowledged that their code sample didn't have it spelled out that if you set 1 gigabit per second of provisioned throughput that you're going to pay through the nose for it. They refunded the throughput costs. But be careful with that. My final case study is going to be about doing machine learning on Lambda. The difficulty with this is, again, with the binaries. In my case, what we were trying to do is we were trying to predict whether a trip was business related or non-business related. You can see here a very grainy decision tree that was generated by XGBoost, which is the machine learning model that we were using, where you feed it a whole bunch of features and then it's able to spit out whether a given trip is likely to be a business related trip or not. XGBoost weighs about 250 meg, which makes it pretty hard, but I use the same fat Lambda trick to get it to work. Here's the code within the Lambda, where we're passing in a whole bunch of features. We're using Smote to do some rebalancing of the data set, because you get issues, in our case, where 80% of the trips weren't business related and 20% were. Generally, XGBoost and most machine learning classifiers won't work too well with that. You need to get it to more of a 50-50 ratio. And that's what Smote is good for. You can see here we're then passing the data into XGBoost classifier, generating then a model, and then checking the accuracy on that. What we do then is that if the model on the holdout data on the test data set, if that achieves more than 95% accuracy, then we treat that model as being a good model and we store it in S3. We then have a Inference Lambda that downloads the models, and the models are per user. After a user completes a trip, it will download the models from S3. It will feed in the features for that particular trip, and then it'll get a probability of whether that trip needs to be tagged with the tag that relates to a certain model. Here's the CDK code for that. Again, we've got here the rebuild model dependencies, sklearn, XGBoost. They're pretty big. I think in total, we're running pretty close to the temp file limit. I think we're maybe at 460 meg in the temp directory, but we're able to fit it all in and able to train models like that. And then here's the Inference Lambda, where we pass in, again, the same dependencies. It has to use XGBoost. We're not using TreeLite or any of the smaller, lighter versions of the model where you wouldn't need to have sklearn and all of that. We are using the same dependencies, same technique with the fat Lambda, and then an SQS trigger for that Lambda. I'm going to finish up by talking about where Lambda doesn't work for me. I'm still using ECS or Docker for web servers. I know that some people are playing around with using API Gateway and using Lambda for that, but I personally still like my monolith for the backend API. And I've also got a few analytics jobs which I initially tried to get working in Lambda, but they ended up being too slow. They timed out after 15 minutes. So I find ECS is a good solution for where Lambda doesn't fit. And then thinking about what it would take for Lambda to be the default choice for almost everything for ETL and ML, I'd say the file size limit is probably less of a concern now that we have EFS support. However, execution time is still a concern. It would be really cool if you could have more than 15 minutes. I mean, it was a game changer when it went from 5 minutes to 15 minutes a few years ago. I'd really love to see it increased even further, because there are some things where you can't really use step functions and interrupt it halfway. For example, with some of the database queries that I'm running on our read replica, they're pretty slow. One of the queries might take 15 minutes on its own, and you can't really interrupt it halfway through. Then the other thing that would be handy is RDS proxy. Looks pretty cool, but doesn't work for Postgres 12 quite now, but hopefully that'll be supported in the future. And the other thing that would be pretty handy is a way of, and there probably are already ways, I just don't know how to do them. So if you have ideas, let me know, around using something like Apache Airflow to orchestrate the data workflows. Right now I'm just stringing together SQS queues and it feels a bit hacky. Just like Lambda functions, my speech is about to time out. I'd like to leave you with a job opportunity. GoFar is hiring a backend developer to continue this kind of work. If you have better ideas on how to manage these sort of ETL and ML workflows, love to hear from you. You can shoot me an email at jeremy@gofar.co. That's all I have. If you have any questions or contrary ideas, please shout them out now as I hand back to our esteemed MCs.
Well, what an awesome talk. Thanks so much for joining us, Jeremy. How's it going?
Yeah, really good. Great to be here. Thanks a lot for organizing it.
Oh, you're absolutely most welcome. I'm always a massive fan of serverless data engineering implementation, so it's really great to see how you went with it and some of the sort of issues that you encountered and how you sort of overcame those challenges. You know, a lot of what we're doing with serverless data engineering is on the bleeding edge, but it's great that there's so many innovative solutions out there to sort of overcome these challenges. One of the questions that we had for you, you know, cold starts are quite famous with AWS, with Lambda, but you know, and we know that AWS have worked quite a lot over time to improve cold starts. But with this Fat Lambda approach in regards to, you know, some of the neural network type workloads, have you found that to be much of an issue, and how have you overcome those?
Yeah, it can be an issue depending on your use case. If you were, for example, trying to do Lambda at edge and doing inference as someone is doing a web request, that could be quite a problem because you want really snappy replies. But for my use case where it's happening in a way where we don't care about when it really executes, the main use case here is we're trying to predict whether a trip is business related or not. And it would be fine if that took an hour to run. So generally what happens with our use case is because they're constantly getting new trips in, we don't really have many cold starts. The Fat Lambda cache is already within the Lambda's temp directory. And so the next time it gets invoked, it's already got all of the files there. But if you're in a situation where it was happening sporadically, but it still needed to be really snappy, that could be a problem.
Yeah, so I guess for the folks at home that, you know, perhaps haven't come across this issue before, it's when I guess the initial Lambda is getting invoked, it's having to download this file from S3, load it up into the container, but all the subsequent executions have already done that. And so they skip that initial load time, and that's kind of what that warm Lambda concept is. Is that about right?
Yeah, that's right.
Yeah,
and then
cool.
the other option is also using EFS instead of S3. I mentioned in my talk that I didn't go down that path just because I had already sunk a lot of time into the S3 approach, and at that time EFS wasn't available. But subsequently, one of my colleagues at Okra Solar, he's deployed a PyTorch model using an RNN model, and for that it was too large even for the S3 approach. So what he did is he used EFS to be able to keep the models, because the models were, I think, over 500 meg, and then when you mix in the libraries as well, it wasn't going to work. But if you do that, it works pretty well. I guess the consideration for when to use Lambda for ML is, do you need a GPU? If you need a GPU, don't use Lambda. But if it can work fine with a CPU, then and it's not going to take that long to either train or run inference, then it can work pretty well. I think with the Opera Solar one, I think it's taking maybe 12 minutes. And we're thinking, if we get more data, then we're going to need to either split up the job or maybe move to a different approach.
Yeah, I guess, and also, what you touched on before around the fact that, a lot of this data processing or machine learning is kind of offline. It's not required to sort of return a response in under 150 milliseconds. It can just kind of happen after the fact, while people are just, waiting for a response and things, or not sitting there waiting for a response. And so latency concerns and things like that. And I love hearing about these sort of use cases. It's awesome. In terms of what we've had through the chat, you've talked about, I guess, how you're using CDK to deploy your Lambdas, and how you're packaging up Python packages and things like that using LambCI. Is that correct?
Yeah, and that was purely just because I hadn't heard of the CDK Python packager. I previously, in my last company, I was using Terraform, and for that, the go-to there was using LambCI to be able to get a similar environment to what you'd actually be deploying on Lambda. And since I'd used that before, I just defaulted to it, but I'm definitely going to check out the CDK Python packager as well.
Yeah, we've had two questions come through the chat that are fairly sort of similar, or playing similar angles in terms of, say you could use EC2 servers and you Graviton servers, with greater throughput and better performance, and the reason why you're choosing Lambda. What are you trying to optimize there for? Is it execution costs or operational management and things like that? Could you comment a little bit about what sort of pushed you towards Lambda rather than, sort of managing your own, servers and stuff like that?
It was purely because I wanted to try it. The data scientist who came up with the model originally, we were talking about how to productionize it, and he said, "Oh yeah, you'll probably want to stick it on ECS or maybe use an EC2 instance." I said, "What about Lambda?" He said, "What, are you crazy? That's not going to work." So I thought I'd try it out, and it did work fine. I think for Gofar's use case, Lambda's actually an optimal choice because our model only takes in the order of maybe 30 seconds to train. And I'm talking about, we're typically training about 30 different models per user. And even with that, each model is only taking a second to train. In total, the overall execution is, I haven't seen it go over a minute. Whereas if you were doing something which would take a lot longer to train, then definitely look at Graviton or some kind of fancy way of using GPUs and proper compute infrastructure.
Yeah, totally. So, depending on, I guess, volume and a lot of other inputs, it really sort of, I guess, determines what's the best type of compute to use. It's fascinating. I just love hearing about these sort of use cases and stories, and how you've got these machine learning models to work in Lambda, because I guess it's freed you up rather than having to manage a lot of all the security and patching considerations that you would have on an EC2 and scaling as well, I'm guessing, right?
Yeah, it's a bit like in the talk about the New Zealand mapping service, that we can have a whole lot of load and we can scale out. I do have to be careful about the impact on the database though, because we don't have an RDS proxy that we can use yet, because we're using Postgres 12, and I don't think, unless it's changed in the last couple of days, I don't think the RDS proxy supports Postgres 12 yet. which means that if we have too many of these Lambdas running at the same time, we'll smash our database, use up all the connections.
All right. And what sort of impact does it have on other services?
Not good.
Not good.
It's happened a few times where I've forgotten to set provision currency and concurrency, and then people are complaining, how come I can't log into the app anymore? Something seems to be wrong.
All right, so that's the provision concurrency on AWS Lambda. I guess
Yeah.
that's kind of a way of throttling and helping to preserve the connections to the Postgres database. Yeah, that's really cool. So there's a lot of knobs and dials that you can use to make it work in a serverless space with the serverless type implementation. So that's has been really insightful. So thanks so much, Jeremy, for joining us today. I think we got a lot out of it. I'm certainly happy because we've got a really cool serverless data engineering use case. So thanks once again, and yeah, cool.
Thanks a lot for having me.
Awesome. We'll just take a very short break. See you in a bit, folks.
Welcome back, everyone. I'm now excited to introduce our next speakers, Amay and Owen, who are going to be talking us through the building of a lightweight serverless data pipeline using AWS Fargate with ECS. Confessed data nerds, as we all are. They're colleagues, they're friends, and they enjoy challenging each other on almost everything, to an extent that the team wonders if they're going to end up fist fighting. So hopefully we don't have that today, but they're going to share their experiences creating a simple, lightweight data pipeline to solve one of their data engineering challenges. The benefits of the approach are that it's serverless, simple, flexible, and it uses Fargate, ECS, and Airflow. So without further ado, take it away, Amay and Owen.
Hi all, I'm Amay.
Hi all, I'm Owen.
Hi all, I'm Amay.
Hi all, I'm Owen.
We are data engineers working in the data collection and platforms team at carsales.com.au. Our team is responsible for delivering data solutions for global businesses of the company. Today, we are going to share with you about how we built a lightweight serverless data pipeline using AWS Fargate with ECS and Apache Airflow. Okay, Owen, so where did it all start?
Well, it started with the business requirement for a project where we needed to serve reporting across 3 different countries which have respective operational databases and designs. After our initial analysis, we realized that we needed to do data cleansing and transformation to standardize the data for reporting. One example is conversion and partitioning in ETC timestamp. Also, we wanted to ensure that the data consumers are able to easily integrate the result dataset with the other tables in the data platform.
Yes, and we had to do this within a short time as well, isn't it, Owen? So how did we progress?
Oh, because we are a team of Spark developers and we are generally comfortable in delivering projects in PySpark. So we initially were contemplating something like this pipeline, where we follow our normal design pattern by using Lambda Airflow to spin up EMR cluster on schedule to run the Spark applications. Then the Spark application on the EMR cluster does the extract, transform, and loads data into S3. This data then is available to be used by our data consumers. They generally connect to this data via Amazon Athena or Redshift Spectrum. But do you remember, Amit? We felt that for this lean transformation and cleansing required for this particular job, we can probably keep it simple.
Yes, 100% Owen. So on introspection, we found some points to reconsider in that pipeline. At the scale or data volume required for this project, we don't really need to use Spark or distributed environment. Just to provision or spin up an EMR cluster, it would take around 10 minutes on an average. However, this pipeline, the total runtime of this pipeline would be less than 10 minutes. Having simple Dockerized Python jobs would make it easy as we don't have to worry about cluster configurations. If there are no benefits in using a distributed environment, we should simplify our development, deployment, and maintenance process. During this design phase, we came across a blog by Mike Krieger where he mentions about running pipelines on Airflow and ECS, Apache Airflow and ECS. So after discussing in the team, we concluded on this serverless pipeline where we use ECS Fargate to spin up a Docker containers and then execute our Python jobs on them. During start of the implementation, we found AWS Data Wrangler package, which provides very cool utilities and abstractions for using pandas on AWS services. We use Airflow to schedule our ECS Fargate tasks, executing Python ETL jobs. So basically, our data source and target remained the same, but we were able to use lean and simple serverless learn Python applications as opposed to complex PySpark application on distributed EMR clusters. Here is a sample code for explanation. So this code is of an Apache DAG with ECS operator. On the left-hand side is a simple representation of the Airflow DAG. It simply means that we have three tasks which are run in parallel and in isolation. So each respective businesses are pipeline do not interfere within one another. On the right-hand side is the implementation of the ECS operator, where you can see the launch type is ECS Fargate, which makes it serverless. We use the environment variables to pass the contextual information to the application that the application needs. For example, we pass the region and country code based on which the application decides the data sources to use, which one to choose for a respective job. So, Owen, right now we went through how we implemented the new pipeline. Do you want to talk about why this pipeline is better in this context?
Yes, Amit. We are all data people, and we like facts and figures, don't we? So we have prepared the table for comparison. From a development and maintenance point of view, running a PySpark application on distributed cluster is not as simple as running a Python pandas job in a Docker container. We don't need to spend efforts on calculating the required resources or cluster configuration on EMR. This also makes our development phase easy, as we can build and test the app locally. There is also a big win on provision time. Because Fargate is serverless, there is practically no visible time needed to provision the resources. On the other hand, EMR needs about 10 minutes on average to spin up the cluster. After deployment with ECS Fargate, we are seeing that the whole ETL pipeline runs for only about 5 minutes. Speaking about cost, We calculated that Parquet is cheaper than running an EMR cluster for this pipeline. We are also able to fine-tune the CPU and memory required to run the job in an efficient manner using ECS Parquet. We are still able to provide the same serving layer, which is really cool. The loaded result dataset is in Parquet format, partitioned and stored in S3. And it's accessible by Glue data catalog via Athena or Redshift Spectrum. So there's no impact on data consumers at all.
Thanks for the really nice summary, Owen. So what is the magic wand that saved us a lot of time while developing this ETL pipeline?
Okay, here is the big reveal. It's the AWS Data Wrangler package. To get you familiar with our magic wand, I'll briefly walk you through the package. It's an open source Python library developed and maintained by the AWS team. It enables us to use Pandas data frame to read and write data on AWS. It also provides handy APIs to use AWS services like Amazon S3, AWS Glue Data Catalog, Amazon Athena, and other databases. I mean, do you want to take everyone through some of the practical examples?
Sure. Let's go through a couple of examples to show the benefits of using this package and why is it so awesome. The first example in this slide is to show how simple it is to write data into Athena tables using this package. On the left-hand side is a sample code to write the pandas data frame to Athena table. The API s3.2 Parquet accepts flexible parameters to deal with partitions and to insert, overwrite, and append data. This API provides schema evaluation out of the box. That means if the pandas data frame happens to have a new column which is not in the Athena table, the package will detect it and add it into the target table. It can also add a new table in the Athena catalog. On the other hand, if you see and think about what do we need to write, what code do we need to write to achieve the same thing in native pandas API or Boto3 calls, we need to do the following steps. First, we need to find the S3 location of the table by using Boto3 Glue Client API. Then we need to save the Parquet data into that S3 location. We then need to run a command to repair the Athena table partitions or add this new partition into the Glue catalog. If there is a new column, we need to explicitly add it into Athena table as well. So this was the first example. Now let's go through one more example. So the previous example was about loading data into S3. Here, we want to give you a quick example on how easy is it to read data from AWS services. On the left-hand side, we are using Data Wrangler to load data into Pandas data frame using AWS Wrangler API wrappers for S3 and Athena respectively. So you can see it's just one simple line of code for both the API calls. Whereas on the right-hand side, we can see that while doing the same with Boto3 library, we might have to write different lines of code and probably map the data to Pandas data frame explicitly. In addition to these, AWS Data Wrangler has very handy APIs to interact with other AWS services like Redshift, Glue Data Catalog, etc. Well, these were some of the benefits. Do you have more to add, Owen?
Well, I think you have covered some of the benefits I made. What I want to talk about next are some of the implementation-specific challenges we came across. So the first challenge is working with complex data type. As you can see from the screenshot, when we try to read a column with the array of struct data type, it throws the reading list of structs from Parquet file not yet supported error. It's not really a limitation on the AWS data wrangler package itself. It is a limitation on using pandas to work with Parquet files. But don't worry, there are possible workarounds. To read the data, we will be able to analyze the array of struct column in the SQL query and pass it to run in Athena. So when the data is loaded into pandas data frame, it's no longer an array of struct data type. And to write the data, we use the approach to first write all data into the two staging tables with one-to-many relationship. Then we run a SQL query which aggregates the required columns into an array of struct and insert them into the target Athena table. So the second challenge we had was related to the driver support for MS SQL Server in DBA environment. One of our data sources is MS SQL Server. At this point, the data wrangler package unfortunately doesn't include driver for MS SQL Server. So to make it working in Docker container, we had to install the required packages in Docker file. This issue wasn't straightforward to solve, and we had to spend a fair bit of time to conclude the fix. As you can see from the code, which is point 3, we ended up using native pandas API calls with PyODBC to load data from MS SQL Server into pandas data frame. I think these are some key challenges we faced during the implementation. Do you have anything else to add, Amit?
Thanks, mate. That was great. Thanks for sharing. I think these are enough challenges for speaking in one session. So before we finish, we want to mention and acknowledge the references that helped us build this pipeline. Also, we wanted to thank the team who worked very hard on this pipeline and task. Thank you so much.
Welcome back, everyone, and thanks for joining us on AWS Community Day. And a very warm welcome to our two speakers who have joined us for some Q&A. We have a couple of questions in the chat, but I think I'll kick us off with some of my questions. I'd like to know how you deployed this pipeline. So you can...
Okay, so we use Jenkins as our CI tool. So right now, the way it works is Jenkins creates a task definition, and then Airflow ECS operator creates a task based on the latest version of the task definition, and then it runs the task. So if we do any changes to the pipeline, we deploy it via Jenkins, task definition is updated, and then on the schedule, Airflow ECS operator is kicks off the ECS task. To deploy the DAG itself, we have another Jenkins job, which basically deploys it onto the Airflow server.
Nice.
Does that answer your question?
Yeah, that's perfect. Yeah, sounds nice and simple. Yeah. Did you come up against any challenges or any potential roadblocks with this project?
Yeah, there are certain limitations when we are deploying this ETL pipeline. So first is something like we mentioned in the video in the chat, is when there is a complex data type. So when we are using array of struct type column, something like quite common in Spark, but when we are using that with pandas, there is a problem, like because pandas using PyArrow or FastParquet to read those type of data, and it's getting something, either it's throwing list of listing out this kind of data column is not supported, or it's returning no value for the whole column. So that's the first limitation. And also one thing we find out is when we are reading the whole table from different data sources, if there is a one particular column has no value throughout the whole column, and it's throwing error when we are trying to read and write this whole thing back to Athena. So what we did, we had to set up some default value to fill in the nulls before actually saving that back to Athena tables. Do you have anything else to add, Amit?
Yeah, one challenge we see, and we faced it only once so far, was data volume. So if there is a sudden increase in the source systems, because we set up the memory soft limits and hard limits in the ECS operator, we might run into memory issues. But we recover as soon as it fails. We have hookups with our failures on DAGs in our Slack channels and our SMSs with PagerDuty as well. So then we just we recover very quickly from that.
Oh, nice. Sounds like you guys have got it all covered. Did you come up against any fist fights or anything while you were with this project? Sounds like you guys are the best of friends.
It happens like every day. I come.
Yeah. Data and drama. I like it.
Great to see you so passionate about the space. So I guess you're using Fargate, another serverless technology, rolling out serverless containers for your compute, which is really cool. Is there a point where, perhaps Fargate becomes a little bit too costly and you might sort of go towards your regular old ECS where you're managing the instances? And have you got any comments around that?
Till now, we haven't run through that, but there was one scenario where we have other APIs running on ECS clusters. So those ECS clusters might have some space already. So it's good to probably run them on those ECS clusters which have free space. We did that for some time, but then we felt we can run into scaling issues. So we are running on Fargate. So if there is space for some simple applications, we have the option of running it either Fargate or on ECS.
Yeah. Also, I think it's very easy to switch between two language type as well. Just specify if you want to use ECS or Fargate as a language type in the ECS operator, then yeah, that does the thing.
It was almost a trick question. It sounds like the cost is that insignificant that it's not a major worry, which kind of goes to the point where like these serverless modes of compute are quite I guess the value prop there is incredible, isn't it? Because reduces that whole management overhead. Cool.
Yeah.
So we do have a couple of questions coming through on the chat. AWS Data Wrangler, is it applicable for unstructured data?
Yeah. So it has some limitations because it works with Parquet, and PyArrow is not really yet compatible with arrays of struct type, complex types in Parquet. And Owen shared one of the examples in the slide. Owen, do you want to reiterate that?
Yeah. What we were processing mainly with the relational databases, so the data structure. I think we can actually read data which is like Parquet or some like JSON, which is semi-structured data type from L3. And when the data type like has very complex data structure, then it might throw some errors, and it's very easy it's very hard to deal with those type of data. I think in that case, maybe using Spark is better because it has better support for those structure. Yeah.
So Spark by default gives schema evolution in terms of when you read unstructured JSON or JSON files, it can read data at nested levels, so which is pretty handy. So if it is really unstructured data where you don't know the schema in advance, probably Spark is something we would try.
Yeah, very cool. Another common question that gets asked in all of these sorts of talks is how do you handle schema changes from your source systems? Is there something that you've built into your pipelines?
Okay, so with schema changes, depends on the layer for us. For example, if something related to data lake, we want data lake to be non-intrusive. So self-serving environment where if a schema is changed to pick it up dynamically. But in case of ETL or transformation pipelines, we most likely from our experience, we need to know the schema in advance. So
Yeah, we are pulling that data only needed for this full reporting. So if there is a new column added in the original data source, if you are not aware of that, then we will pick up. And if that's needed, we need to go and update the SQL we use to pull the data. So that new column or new things will be included in the destination in data lake, basically.
Yeah, cool. And just in terms of we've had a couple of questions coming through from Dipti Potluri. He's asked, could you talk a little bit about data management with this ETL pipeline in terms of like data cataloging, consistency, lineage, and these sorts of things? Is that something that you've built out capability around?
Yeah, that's a very good question, and probably need to cover a lot of time. But to put it simply, refer to data catalog, we are using Athena Glue Catalog. If we have plans to build a proper data dictionary, but we are very early in that stage. With data consistency and lineage, we annotate data or entities that come in data lake, and depending on transformation, we try to carry that lineage forward. In terms of job lineage, we have job logs which we maintain ourselves, and we use that to track the job lineage as well. But yeah, there are a lot of many things here, so we can probably chat offline, Dipti.
Yeah, it could be a future talk, perhaps.
Yeah.
But no, I just wanted to thank you on behalf of myself and Helen. That like really great, fascinating talk. Awesome to see Airflow and Fargate and stuff, and a really cool solution at a great Aussie company as well. Car sales. So keep up the awesome work, and yeah. Thanks once again for joining us. We're going to display a QR code shortly where you can give us some feedback on all the presentations, and as well as how myself and Helen and the whole operation has been running today. So please do fill those out and let us know how we can improve in the future. But round of applause for our speakers once again. Thanks so much. Cheers.
Thanks for having
Thanks for
us.
the opportunity. Thank you.
Welcome back, everyone, and thanks for joining us for AWS Community Day. I'm now really thrilled to introduce our next speaker, Olivia Carline. She's going to be talking about real-time data analytics through Amazon Kinesis. Olivia is a solutions architect with AWS, working out of Melbourne as part of the public sector team. Worked in Wellington and participated in the TechU program based in Singapore. Her talk today is going to be about how you can create and build your own real-time analytics solution with the Kinesis suite of products, starting with common use cases, design patterns, and then finishing up with a step-by-step demonstration on how to ingest and get insights from your real-time data. So without further ado, we will cut to the video of Olivia.
Hi everyone, thank you for joining my session today. I'm really looking forward to talking through the importance of real-time data analytics and explaining how you can leverage the Amazon Kinesis product family to achieve your data streaming goals. So a little background about myself before I dive right into it. I'm Olivia Carline, an Associate Solutions Architect here at AWS. I initially joined AWS a few years ago, working as an intern out of the Wellington office. And then after completing my degree, I returned back to complete the TechU graduate program, which is a really fun initiative that basically provides an accelerated pathway into technical roles here at AWS. After completing the graduate program last year, I moved into my current role where I now work in the public sector solutions architecture team. So that was a little bit of an aside, but if anyone is interested in learning more about opportunities for students here at AWS, please feel free to reach out directly or message me and I'll be happy to answer your questions. But yeah, as the title says, why I'm really here today is to actually talk through, why real-time streaming data is important, and then explaining some of the services you can leverage on AWS to get started. So without further ado, let's take a look at the agenda. So we're going to begin by talking through the common streaming data processing pipeline and what that looks like. Next, we're going to dive into 3 out of the 4 Amazon Kinesis products that can be leveraged to achieve your data streaming goals. And I'll close up with a really quick introduction on some resources you can go to if you're interested in getting more hands-on with Kinesis. So we do only have a limited amount of time for today's session. So the services that I'll be talking through will be at a really high level. So we won't be going too technical or going into any of the features or into too many details. But I would like to start by going through what the pipeline looks like when it comes to your streaming data. As the illustration shows, there are 5 core stages to understand when it comes to your analytics pipeline. And as you'd expect, we do start with the source. This is where your data is coming from. And typically it can be things like your IoT devices, or if your server's generating logs or application logs that you'd like to analyze and monitor. But we also have stuff such as, clickstream data on a website that are also really great use cases for your real-time analytics. Once we've got our source data, the next thing we have to do is to actually start ingesting it. And then so it's really important here, because of the way that real-time data is, you don't really necessarily have insight into the volume or the velocity at all times. So it is important that your ingestion of this data is able to actually scale out and be able to meet the demands as your needs change. Once you have your data being ingested, the next step is to actually temporarily store it, and you do that for a limited period of time before you start to really get to the good stuff of this pipeline, which is the actual processing of it. So this commonly looks like your real-time transformations, if you want to edit your data, or if you want to perform real-time analytics on your data right away, this would occur in this processing stage. And this all happens before you actually have your data being sent out to your final destination. And this typically includes stuff like your data lake or your data warehouse. And all of these stages that we've got up here can actually be configured and enhanced by leveraging the Kinesis suite of services. So we do have, within Kinesis, we have 3 core services for your data streaming, but we also have a 4th one for processing your video streams. And although we won't be covering Amazon Kinesis video streams in any real detail in this talk, I do want to quickly mention that it exists and it allows for you to stream and analyze your video and your audio data in real time. But the first data streaming service that I'll be talking through is Amazon Kinesis Data Streams, and this allows you to collect and process your data records in real time. This is followed by Amazon Kinesis Data Firehose, which provides a really simple approach to capture, transform, and then load your data into data lakes or data stores. And then finally, we have Amazon Kinesis Data Analytics. And this allows you to process your data streams in real time through either SQL or Apache Flink. Let's have a closer look at Kinesis data streams. So this service makes it really easy to reliably ingest and then store your streaming data. And it's great if you're going to be using any custom applications to process your streaming data. And one of the main benefits that comes from leveraging Kinesis data stream is the fact that your streaming data is actually available to any consumers or to any analytics applications that you've built within 70 milliseconds of your data being collected. And this is really great because when you are dealing with streaming data, the benefit really comes from being able to access it as quickly as possible. And this value diminishes the longer it takes to get access to it. But another key benefit of leveraging Kinesis data streams is the durability that you get. And because your streaming data is synchronously replicated across 3 availability zones within one AWS region, as well as having the option to actually store your streaming data within this data stream for up to 7 days, you do get quite a lot of comfort knowing there are multiple layers of protection against data loss. But if we just have a look at this diagram that we've got up on the slide, you can see that we have really 3 key stages. So we've got actually the data producers coming in, so that's the source of our data. And then we actually have the actual Kinesis data stream. And the great thing with Kinesis data streams is the fact that Amazon does manage the hardware and the that's required to actually configure this. And so through this approach, you can actually dynamically scale out your data streams very, very quickly based on the volume and velocity of the data that you're seeing. And this can really be easily achieved just by adjusting the throughput of the stream based on the volume that you're expecting. But then once the data is actually in the Kinesis data stream, the final step is to actually have your consumers actually accessing this data. And we do have a whole suite of different services as well as third-party tool integration that I'll talk through in a later slide that explains the various options. But let's start with actually ingesting the data. So with Kinesis data streams, we can have data from tens of thousands of different data sources, all being written to the same stream. So we do have a number of different tools and utilities that are available to make this process a lot easier. And we typically break this up into 3 different categories. So if we start with the toolkits and the libraries available, this includes stuff such as the Amazon Kinesis Data Streams API, as well as the Kinesis Producer Library, and this provides a really simple interface to actually package up multiple messages and then compress your data when you're sending it to your stream. But we also have the Kinesis Agent, which is a pre-built Java application that you can install on your servers. And what this does is it will monitor certain files and continuously stream that data to your stream. But we also have different AWS service integration. So you can have such as AWS IoT, which is great if you're dealing with a smart city workload, but you can also have Amazon CloudWatch. And so if you want to have, this event data that you're monitoring being pushed through in real time to analyze, we do make it really easy to kind of set up and configure. But alongside that, we do have third-party offerings that are available. So a few that I want to call out here include Log4j, we've got Flume, and we have FluentD. And these provide some adapters to connect to your Kinesis stream and make it really easy to actually get the data being pushed through. Similarly, when it comes to your actual processing and your consumption of the data, we do have quite a few different options that you can choose from. And like I mentioned, the great thing is this data will be available to your consumers within milliseconds, and it will arrive in the order that they were generated. So this enables you to actually get started building out these real-time analytics and really start getting insights from your data very quickly. So once again, we can break the data consumers down into 3 different categories. And if we start by looking at the various tools and services that are available within the Kinesis product family, we can actually start by having we can start by using Kinesis Data Firehose. And what this looks like is we can have our Kinesis data stream being a source, going to a Kinesis Data Firehose, and then connecting that up to S3 or to Redshift if we want a permanent data storage solution. Similarly, we can connect our Kinesis data stream to have it going into Kinesis Data Analytics application. And this will enable us to start getting, really actionable insights very, very quickly. And I'll talk through both of these services later on in more detail. But like we did with the producers, there are a number of different libraries that are available that you can leverage. This includes the Kinesis client library as well as the Kinesis connector library, and this actually provides a very simple mechanism for integrating with other AWS services and third-party tools. But there is also the option to just connect very directly with AWS services, and in particular we have AWS Lambda. And what the common approach to do with Lambda is to actually have these Lambda functions subscribe to your Kinesis data stream, and these will automatically read records from the stream and then process or perform event-based processing of your data. But if you prefer, there are also third-party tools that are available. So the most popular of these is Apache Spark, and that allows you to utilize Spark streaming off of the Kinesis stream. But we also have a range of other tools such as Datadog or Splunk that allow you to just pull off the data from the stream directly and process it. So the next service that I want to talk through is Amazon Kinesis Data Firehose. And this is a fully managed service, so it automatically provisions, manages, and scales out the resources required to do this processing and this ingestion and loading of your data. And it it is actually one of the easiest ways to load your streaming data into data lakes or into data warehouses on AWS. Through Firehose, you can actually capture, transform, and then load your data into Amazon S3, Amazon Redshift, or Amazon Elasticsearch Service, as well as integrating it into Splunk. And this allows you to develop near real-time analytics applications. So if we look through in more detail what this pipeline actually looks like, we do have 3 main steps that we need to go through. So we have ingesting the data, transforming it, and then delivering it. So just like with Kinesis data streams, there are actually quite a few different options you can configure as your data source for your Firehose. So you can choose to have your data being pushed directly from the source, whether that's application logs on a server or if that's an IoT device. You can have it configured to go directly into your Firehose stream. But like I mentioned, there is the option to actually chain these services together. So to start with a Kinesis data stream, and with this approach, you would have your analytics occurring in real time from the data stream if you needed insight very quickly, but then you'd also have the data going into your Firehose to be delivered into your data lake to perform further analytics, on a longer term scale. But once you've actually got the data inside this Firehose, the next step is really to transform it. And there are a couple of different transformations that you can achieve, and they're all really done through Lambda functions. So a common transformation that we do see is people will transform the data format that they're dealing with. And this is great, for an example, if you're leveraging Apache logs, and these all come in a row-based format. And let's say we actually want to convert it into a Parquet columnar format. We can do this through Kinesis Firehose without having to set up a separate ETL pipeline to achieve this. And through this, we can actually get really good performance from our analytics application by using this new format. And through this, we no longer need to spin up an EMR cluster or build out any glue jobs to execute these transformations. They are all done in a very simple process as this data is being collected and being processed before being moved into the next data store. And this data store is a final stage in this pipeline. So like I mentioned, there are 4 destinations. So you've got Amazon S3, which is great if you're building out with a data lake solution. But otherwise, you can use Amazon Redshift for your data warehousing solution, or Amazon Elasticsearch Service. You can have that being configured and then start doing analytics through that. Or we do have a third-party integration where you can push your data into a Splunk instance before going into the next phase. But this approach in this diagram does look a little bit similar to the Kinesis data streams. And this is a common question that customers raise is, what is the difference and when should you use which service? So I do like to include this slide just to really kind of give a better explanation of, the differences between the two services. So if we start with Kinesis data streams, this is really great if your workloads require custom processing. It's also super important if you're going to require sub-second latency that you go through Amazon Kinesis data streams. But just bear in mind the fact that this service does require some manual scaling and provisioning as your data input and your data volume grows. On the other hand, we have Kinesis Firehose, and this is really, really a great solution if you prefer zero administration. So if you want everything to be taken care of for you, Firehose is a great service to leverage. Critically though, your workload has to be okay to have a data latency of 60 seconds or higher. And then finally, the third service that I want to talk through is Amazon Kinesis Data Analytics. And so with Kinesis Data Analytics, you can actually tap into these data streams or these fire hoses and query this data in real time. And so this can be done through either SQL queries or through Apache Flink applications. And the great thing is, you've got these built-in templates and various operators that you can leverage to actually organize, transform, and then analyze your data at any scale as it grows. And the cool thing with it is because you process your streaming data with sub-second latencies, you're able to analyze and respond to your incoming data in real time. So you're still getting the access and the insights to your data as quickly as possible. The other benefit that comes from leveraging Kinesis Data Analytics is the fact that everything that's required to run this application is taken care of for you. So these services will scale automatically to match the volume and throughput of your data, so you can focus on getting the insights from your data rather than the administration tasks required. So if we look into it in a little bit more detail, there really are 3 steps that are required. So like you'd expect, we've got to define your input, then we have the actual building of your application code, followed by the configuring of your output. So the very first thing is to define your source input. This is either your Kinesis data stream or your Kinesis data fire hose that you want to start analyzing in real time. And all you have to do in this stage is simply point to this stream or this fire hose, and then Kinesis Analytics will actually automatically read this data and then it'll make it available for processing as soon as it's ready. And then the next stage, and really the main component of this, is the actual analyzing of your data. This can either be achieved through Apache Flink operators or through SQL statements. So if you go through the Apache Flink approach, you do get access to more than 25 pre-built stream processing operators. This is stuff like Windows and Aggregate. And if you go through Apache Flink, you can actually start to build out some really sophisticated real-time analytics applications quite quickly. Alternatively, there is the approach to go through SQL. And with this, you can perform quite interactive analytics. So you can perform joins, aggregations over time, you've got filters in Windows, and a couple of other different features that you can leverage. And with SQL, these steps can actually be chained together, either in serial or in parallel. And again, all of this can occur within a second, just depending on how in-depth these queries are and the type of aggregates you're performing. But then the very last stage in this pipeline is to define your output. So you can either have your process results going through a fire hose again and then being sent off to Amazon S3 or to Redshift for their permanent storage, or you can choose to go through Kinesis data streams in order to build out a more advanced processing pipeline. But that's really it. They're very simple to get started. And if you are interested in learning more, we have, quite a lot of resources that are available online. There's, a large amount of content through the AWS website, as well as third-party training providers and through our partners. This includes stuff like case studies or webinars, and many blog posts and technical documentation is available. We also have the AWS streaming data solution that's available if you want something pre-configured to kind of go through this process when you're just starting off. But yeah, I just want to say thank you for listening. I really appreciate your time coming here today. And I'll now do a very quick Q&A if anyone has any burning questions they want answered. Thank you.
Welcome back, everyone, and thanks for joining us for AWS Community Day. And a very warm welcome to Olivia, who is joining us live to answer all your questions.
Thank you for having me here.
Oh, that's awesome. Yeah, I really enjoyed your talk. Great to get a good overview. I think you did a really awesome job. Cool. While I have you, I'm really keen to hear more about the TechU program and your experience there. Do you want to give us an overview of what the experience was like and what you got out of it?
Yeah, definitely. So it's one of my favorite subjects to talk about because it was just such a cool program to be a part of. So back pre-COVID days, it actually involved a 6-month stint over in Singapore, which was, for obvious reasons, one of the highlights of the time there. Basically, this is for the APAC cohort. So they're a group of us from a couple of different countries, including Singapore, Malaysia, Thailand, and obviously Australia. And so we all kind of get together for these 6 months, and it's basically an extension of university and quite an intensive process where we have to go through sprints that cover a range of domains. So every fortnight we'd learn a new domain. So it'd be stuff like security to IoT to machine learning. And throughout this, you're learning basic communication skills to speak with customers, as well as the actual technical skills that are required. And then following this is the final month of the 6 months is spent on a capstone project. And so we have, free reign to build anything we like. I think the only rule we had was I had to use AWS services, and it was really just get quite hands-on with the services and create something cool that solved a problem. And then following on from that, we actually moved into our more technical roles. So some of us became associate solution architects, others became cloud consultants, and a few became technical trainers. And we just kind of branched off from there into our respective home countries.
Nice. It sounds like a great experience. A real sort of, huge overview of all the things all at once.
Oh, it's great, especially with the new services coming out. It's very, very hard to keep up with them all.
Yeah, definitely. Did you have a favorite sort of area that you got into?
I'm an absolute sucker when it comes to anything security related, especially machine learning, just for all the buzzwordness of it. It was quite a fun time.
Oh, that's great. And your role now is with the public sector team?
Yes, yeah. So I now work as an associate solutions architect. Kind of a bit of people have very different opinions on what that role actually does and the duties involved. And to give a really quick rundown, I don't have any customers that are assigned to me. So I'm essentially a resource for the wider team. So I'm there to help create proof of concepts, to help run workshops, to kind of any technical content that needs to be done. You just kind of call on an ASA to get that done.
That sounds very cool. Yeah, must be some really interesting use cases as well in the public sector.
Oh, definitely is. It's a really fun place.
Cool. All right. So shall we find some questions in the chat? We've got a question from Andy Van Dam. For a non-data scientist, what would be a good learning exercise and data source to try out Kinesis?
Oh, so the great thing is there's so many different data sources that are available online. So I think we do have some really great resources and some labs that I can kind of send a link to in the chat. In particular, we always call out the New York taxi data, and that's kind of the core for a lot of our workshops is based on that data set. And it's basically if you want to go through some serverless applications or real-time streaming data, we have quite a few different options that are available. But if you actually want, your own data set, we typically start with IoT data. You can generate that as well. You don't need to have these devices. We do have an IoT simulator that kind of takes care of that for you. As well as that, any server logs or anything like that is really easy to generate and gives you a lot of value to kind of derive insights from.
Yeah, that's cool. It sounds like it's really easy to get up and running and see the benefits really fast. Very cool.
Yeah, another question that's come through from Andre 2020. What is the cost difference between Kinesis Firehose and data streams?
So absolutely a great question. I don't want to lead you astray by giving you any wrong information. The main thing to bear in mind when it does come down to costs is with Kinesis Firehose, you are getting a more managed solution. So there is some cost involved with that. You know, a lot of the administration tasks and kind of the scaling out is handled for you. Whereas, you know, with Kinesis data streams, you are, you know, a little bit more manually involved and you're kind of in charge of, you know, these scaling out and making sure you have the shards to handle your data that's coming in. So they do come into play, but I can get back to you on that.
Yeah, not a problem. I'm sure you can probably just look it up on a pricing documentation page somewhere. But no, it's good to, I guess, also get the sort of practical reasons why you'd go for one versus the other for sure. No, that sounds really cool. Any other questions, Helen? Or
I think we were looking at the Parquet format transformations.
yes. Can when we're outputting Firehose data to S3, what sort of formats can we output to? Is Parquet available?
Yeah, so we were having some discussions about that on the back end, and you can, you know, definitely change it to Parquet format. Again, it's a very much a it depends situation on your workload. Occasionally, Parquet might not be the best file. You might want to have different transformations depending on how you want to really use that data. So there's no real like, here's a solution that will fit every use case for you. It's just kind of how you're going to be leveraging that data and what do you want done with it.
Yeah, I guess lots of tiny little Parquet files might not be what you're really looking for. You might want to do some sort of batching step that sort of aggregates them all up or something like that potentially.
Exactly. Yeah.
Yeah. Well, fascinating insights. It's great to hear, about, real-time streaming, because it just seems all the rage these days. Batches definitely yesterday's tool, although it's still definitely around in the data warehousing space and stuff. But it's also great to hear from an associate solutions architect here about the TechU program and all the great, stuff happening. Behind the scenes in AWS. So thanks so much for joining us, Olivia. Really appreciate your time.
Thank you so much for having me.
Cool. All right, we'll take a little quick break and then we'll join you shortly. Chat to you soon.
Okay, cool. Welcome back, everyone. And thank you for joining us for this AWS Community Day. I'm really thrilled to introduce our next speaker, Merritt, who is going to be talking us through building a mostly serverless event-driven lakehouse. Merritt is a pre-sales consultant at Servian, focusing on AWS and data. He spends most of his days helping clients solve complex problems with AWS and is an avid technologist, gaming enthusiast, and open source contributor. In this talk, we're going to walk through a solution that utilizes common and sometimes underrated services to achieve a mostly serverless event-driven lakehouse that takes the cost out of the equation and makes dependency management simple. So with that said, we will start the video of the mostly serverless lakehouse.
Hi all, and welcome to my AWS Community Day presentation, Building a Serverless Event-Driven Lakehouse. Before we get started, let me introduce myself. My name is Murat, and I'm a pre-sales consultant at Servian, specializing in data in AWS. I'm a huge fan of AWS, and I love experimenting with the various products and services. I'm also an AWS APN ambassador. Firstly, let's talk about the data needs of our organizations. Organizations want the ability to harvest actionable insights from their data. Organizations are starting to trust what the data is telling them and are learning to build strategies backed by the data, not just gut feel. They want access to tools, products, and services that can support their descriptive, predictive, and prescriptive analytical needs. And finally, they want access to this data in a low cost, low maintenance, and scalable platform. But more importantly, they want access to this data now. They don't want to wait 6 to 12 months to gain their first insight. They want these insights now, and they want to make business critical decisions with current and relevant data. Now that we've discussed some of our organizational needs, I want to highlight several principles that our solution will be incorporating and following. The event-driven principle utilizes events to trigger communication between products and services, as well as triggering processes themselves. This enables us to process data as and when it lands. No daily or intra-daily schedules. This is key to getting data into the hands of our users as quickly and as simply as possible. The serverless first principle prioritizes serverless products over serverful products. To maximize scale and reduce operational overhead, we look to fully manage serverless products such as Lambdas over EC2s. We want to invest in the development of our platform rather than the provisioning and upkeep. The principle of object-based dependencies simplifies dependency management through the use of physical objects instead of the physical processes that load or transform those objects. Managing spider webs of dependencies is time-consuming and often confusing. Managing timings of data loads, file lands, and more can at times be some of the most frustrating work we do as data engineers. And finally, configuration-driven development allows us to utilize configuration information or metadata to reduce code duplication and increase delivery velocity. Let's talk through what a typical data platform looks like. On the left, we have our source systems, our databases, files, APIs. On the very right, we have our consumption layer, typically our BI layer. In the middle, we have our data lake. It holds all the company data in the various formats they arrive in, structured, semi-structured, or even unstructured. A data warehouse that holds our governed and structured data and is generally considered the source of truth for our organization. And of course, an advanced analytics layer where insights are derived. This is a typical data platform. If you were to go back 10 or even 5 years, it would look slightly different. Back then, a data warehouse would typically be your source for all company data. However, it was costly to develop and very time consuming. And to be frank, it would only cover a handful of use cases. Today, we'll be focusing on our data lake and our data warehouse. How do we extract, load, and transform our data in this platform? We want the data platform to be feature-rich, but at the same time, we want to maximize the platform for speed. Speed of adding new data, speed of transforming and processing that data within the platform, and extracting those values. Now that we have a sense of what a typical data platform looks like, let's cover off the AWS services we'll be utilizing to build out this new platform. From over 180 products and services to choose from, this exercise can literally be done in 20 different ways. But since we've defined some of our principles going in, we'll be prioritizing some services over others. Let's look at each service in greater detail and discuss the role they'll be playing in our platform. DynamoDB will be used to store our configuration information. DynamoDB is a highly scalable and flexible key value pair database that suits an abundance of use cases. Glue will be our transformation engine, performing the various loads and data transformations within the platform. Glue is a serverless Spark service It is generally inexpensive when used correctly, and it's a perfect service for our new platform. Lambda will play the coordinator role. A lot of times it's easy to use and abuse Lambda and use it for everything under the sun. But we have to remember that just because something works doesn't mean it's the right thing to do. Redshift is our highly scalable parallel data warehouse. It provides us with the power to store, transform, aggregate, and consume petabytes of data via a familiar SQL interface. S3 is our data lake. What can I say to this? There is no more perfect service for this purpose. It's ridiculously resilient and impressively flexible. SQS will be used for our ordered queuing system, and finally, step functions will be our auditing and orchestration service. As you can see, although most of these services are serverless, Amazon Redshift is very much not. It has come a long way since its inception, and day by day the service is improving, and for that reason, I'm sticking with it. Now let's put it all together. This is what our final data pipeline looks like. All our services connected via events and triggers, no schedules, nothing hard-coded. This simple configuration enables a multitude of possibilities that, at the same time, are flexible and extensible. Our initial starting point is here, in our data lake. Whether the data is pushed into our data lake via a CLI command, Kinesis Firehose, or pulled in via a database migration service, it all ends up in our data lake. Once the data file lands, it will trigger a chain of predetermined events that will process that data until it reaches its final resting place. The second event in our data platform is our processing queue. The queue enables us to process events in the order they landed in, something that is very important when trying to build an accurate historical representation of our data. We'll be utilizing first in, first out SQS queues to ensure order preservation. On top of this, SQS exposes various inbuilt retry mechanisms and dead letter queues, all useful when building out a more robust solution. Once a new message lands within our queue, our coordinator Lambda function is triggered. The message is read off the queue and the Lambda function gets to work. The first step is to retrieve the configuration information for the particular data file that has landed. This is done by matching the data lake file location to the configuration information stored within DynamoDB. The configuration itself can be quite simple, as this example indicates, but can be extended to encompass a lot more. As you can see here, we have a unique ID for this configuration. We store our source data object, in this case a file in a particular S3 bucket and prefix. We store our target data object, in this case a Redshift table within a particular schema. And we store our job name that will perform the load from S3 to Redshift. And along with that job name, the job parameters that are needed for the job to function correctly. As you can also see, our source and target keys can store multiple object references. That's because a single configuration can depend on multiple sources. Or, on the other hand, a single configuration can load multiple targets. We do not want to limit ourselves to one-to-one configurations. Once our configuration is retrieved, our Lambda function will proceed on to the next step. Now, in a situation where a configuration was not found, our Lambda function can simply alert our support team. This event can trigger our development team to consider whether creating a new configuration file is necessary, or they can simply ignore it if no further processing is needed. Now that we've retrieved the necessary configuration data, our orchestration service will proceed with running the load job configured. Step functions enables us to create reusable paths and patterns for our various data platform needs without worrying about job durations, custom error handling functionality, and more. Step functions can be in a state of execution for up to a year, with plenty of out-of-the-box functionality and support for some of AWS's most popular services. On top of that, Step Functions creates immutable logs that can be accessed at any time for auditing and debugging purposes. In this scenario, our Step Functions will execute our glue job. The glue job will receive the necessary parameters that were stored within our configuration table and proceed with the file load into Redshift. Because glue doesn't have the same timeout limitations as Lambda, it is far better suited for more prolonged running workloads while still keeping to our serverless theme. It is also worth noting Glue isn't just Spark. Several years ago, AWS released Glue Python Shell, which is closely aligned to Lambda, but without the execution duration limitations. In this example, we actually won't need to utilize Spark, as our pipeline will only perform a simple Redshift copy command from S3. Likewise, we can again utilize Glue Python Shell whenever we want to transform data within Redshift itself by simply executing SQL commands and waiting for them to complete. Glue provides a simple, flexible, and cost-efficient service for most of our needs. In those scenarios where data transformation is necessary, Glue Spark can be utilized to transform data directly within our data lake without the need to load the data into Redshift first. When using Glue Spark, however, I suggest the use of Spark SQL, as this will enable us to create configuration-driven Spark jobs that can simply take a SQL statement as an input to do its processing. Without Spark SQL, we'll be forced to build bespoke Glue Spark jobs for every different transformation or load. Once the data is loaded into Redshift, we can stage the data for further transformations up the value chain. We can also historicize the data, enabling point-in-time lookups, and more. Now that the data has been loaded into Redshift, any further transformations of that data should be typically conducted within Redshift itself. We want to utilize the parallel nature and massive scale of Redshift to our advantage. We also want to avoid the costly and time-consuming process of extracting, transforming, and loading the data back into Redshift. In most cases, SQL is powerful enough and flexible enough to perform necessary transformations. After the load into Redshift completes, Step Functions will perform the next step in our event-driven pipeline. It will publish a new message into our processing queue. Remember our configuration data? Well, in there, we specified our source and target objects. These objects enable us to build out our object-based dependency graph. Thanks to this information, we now know which objects were impacted by our data load. This allows us to use that information to trigger the next set of jobs that depended on our target object being loaded. By inserting our target object into our process queue, we enable our platform to retrieve and execute the next set of jobs. This process will continue until the very last target object is loaded and is no longer a dependent object. This is object-based dependencies, and this is how it can be easily modified by introducing more object dependencies, removing object dependencies, or changing the object dependencies within existing jobs. All of this is achieved simply by introducing new configurations that depend on existing objects or by creating new ones. No need to modify orchestration jobs, DAGs, or custom scripts. Now that our pipeline has completed its very first execution, it will continue doing so in the same manner for every execution to come. Simply by changing the configuration and execution of specialized glue jobs, we can cover a multitude of data platform scenarios, including data profiling, data validation, data loading and transformation, extraction, tokenization, and many more. The pipeline I've presented to you today can be thought of as an execution framework that can be extended for the various use cases, all whilst conforming to the same simple pattern. We only need to change the functionality within the glue job to perform the various functions. And if glue is not the right service for your use case, it can be simply exchanged for another. Remember, this pipeline is only a demonstration of what's possible, and I've only run through a single use case. Your usage may vary. In some instances, you could remove the data warehouse entirely and keep everything within your data lake. In other instances, you may substitute the data warehouse for a simpler RDBMS or a NoSQL database, or you can have all three. Before I wrap up, I want to highlight some key takeaways. There'll never be a one size that fits all. There will always be an edge case or two that either can't or are too difficult to solve with an existing solution. It's okay to accept that, and it's okay to build something more bespoke to handle that edge case. At times, it's a lot harder to make an existing solution work with an edge case than it is to build a new solution for that edge case. And finally, there is no best practice. There is simply what's considered good practice today and what will be considered good practice tomorrow. We have to know when to adapt, when to rework, and when to introduce new patterns and solutions so that our solutions can stay relevant and up to date. Thank you for tuning in and watching. I hope you've learned something new today and enjoyed the presentation.
Welcome back, everyone, and thanks for joining us for AWS Community Day. And welcome to Murat, who is here with us to answer all your burning questions about serverless and lakehouses. Thanks, Murat.
No worries. How are you all?
Doing good, doing good. Yeah, loved your talk. I'm into data warehousing and data lakes, so that spoke to me. Loved it. I had a couple of questions, so maybe I'll kick off with that and then we can hit the chat. So what type of organizations do you see this solution working for?
It's a good question. Typically, once you go enterprise, so once you go to the big banks or telecommunication companies, there's a lot of edge cases that start coming in that make having a single solution that sort of encompasses all those edge cases quite difficult. So I'd probably steer away from building something too serverless and too sort of unique for enterprise grade. But I'd say your corporate companies, your typical sort of tier 2 companies, or your that emerging enterprise that AWS calls them, would sort of be the perfect company. You're looking at companies that don't have a lot of internal sort of capability, and also companies that want something that's quite easy to stand up and easy to maintain, that don't have millions of dollars worth of budget. You know, you go to a bank and they can throw millions of dollars at projects, whereas you go to corporate companies and they can't. And that's where I think something like an event-driven serverless architecture really benefits those smaller companies. But at the same time, over time, as we mature in that data space, event-driven serverless will become more and more prominent within those enterprise customers as well. But it'll probably be a bit more sort of sophisticated and mature than the solution that I showed today.
Yeah. It's interesting to see, how the technologies have changed, and especially between the big enterprise and the startup, and so many options.
Yep, definitely.
Yeah, how do you see serverless technologies changing the way we build these data platforms?
So if you look in the past, you very much had your ETL tools, your extract, transform, load tools doing all the processing. Serverless allows us to scale. It gives us the ability to scale to hundreds of thousands of jobs processing at the exact same time. So I think that's definitely something that we need to think about how do we consume data. So instead of consuming data on a nightly scale, like in a nightly batch where we're just getting all the records in at the exact same time, we need massive power, massive compute clusters to process it. Maybe it's about getting sort of small extracts throughout the entire day and processing small. Because the problem, I guess, with serverless, you look at tools like Glue, or you look at tools like Lambda, there's a compute sort of ceiling to these tools, Lambda especially. You can't throw terabytes of data at Lambda and expect it to process it in one file, as an example. You need to break it up. So instead of doing an extract of 100 million records overnight, instead maybe do it every minute and only process 1,000 records every minute. By the end of the day, obviously, you've processed the same amount of data, but serverless allows you to scale out instead of having to scale up all the time, which is sort of the traditional way we used to do it, right? Just throw more compute at it, bigger server will just handle more data and you're good to go.
Yeah, throw more money at the problem.
Yeah,
Cross out
that's it.
Yeah, maybe we'll switch to the chat now. I see that you've already sort of taken this one on already, but maybe we could talk it through as well. How do you balance the use of first in, first out SQS queues limit against the ability to scale out in parallel?
Yeah, so it was a good question. Originally, when I thought about this, we just designed it with just normal SQS because obviously there's less limitations. But when you now think about building up that historical layer of your sort of either warehouse or your platform where you need to understand what record came in first, what record came in second to modify that record, you now need to say, okay, well, actually, I need to process record A before processing record B. And that's where first in, first out queues come into play. As I mentioned there, sort of you're looking at a 300 sort of messages per second limit or 3,000 in a batch. So if your Lambda reads a batch of 10, you've got that 3,000. And now with the release of SNS sort of, ordered topics, you can move to SNS if there's potentially a better limit over there. But at the same time, you could probably do a switch. So you could say, for this particular bucket prefix, I actually don't care about order, and I'm going to go to an SQS queue that is not a first in, first out queue versus this one that does care about order and take that one. It's sort of like UDP and TCP, right? Whether you care about that response coming back or not. Maybe you don't care about order because they're transactions, and transactions don't have history because you made a purchase today and you don't made another purchase tomorrow. You don't really care about the previous day's purchase. Whereas something like a customer updating their address, well, you do care about what the address was before this next update. So you could do that split and then gain, I guess, a little bit more performance there. I would generally say at the corporate companies that I've worked in, at the enterprise companies that I've worked in, 300 per second is decently performant. If you really need more than that, yeah, maybe you're doing some other scales that I'm not aware of.
Yeah. Cool. I think we've got one more question in the chat from Elvis Schmin. I have serializable isolation issue on AWS Redshift. If we want to integrate data to Redshift concurrently, what would be the best solution instead of a message queue service?
So the serializable isolation, I can't remember if I've hit this problem before as well. If I remember correctly, I think that's where you're trying to modify a record with another query at the exact same time. So you're having issues basically isolating two different updates. And it's because of the ACID compliance of Redshift, right? Like everything needs to be ACID compliant. So a particular write needs to ensure that you're going to read the exact same data from after that write is successful. So what you want to make sure is that if you are updating an existing table, that you create a queue that potentially does those updates sequentially, because you will be updating potentially the same row in parallel. If you are just doing inserts only, which is how we've sort of worked around this. So when you look at data warehousing and you look at things like the data vault sort of method, modeling methodology by Dan Linstead, what you typically say with that one is when you move to data warehouses in the cloud, you typically want to create write-only data warehousing. So instead of updating records and end dating them to say the record was valid from today till tomorrow, you just really want to do inserts only. And then on your read, you then generate that history of when was that record end dated. So instead of updating, maybe just convert your warehouse into a write-only data warehouse, which has taken the paradigm from your data lakes, your Hadoop style platforms, where updates were very slow and very cumbersome. So instead they moved to, let's just write only, so append only. And whenever we need the actual point in time history, we'll do that on the read out instead of on the write in. So maybe do that instead of sort of working around the queues and sequentializing everything.
Yeah, that's good advice. Yeah.
Very cool. Just a bit of a left field question. You've talked about serverless data lakes, Murat. And the benefits of using serverless. The less infrastructure to manage and things like that. what are you seeing with customers in terms of, I guess, the additional headspace that gives them and their ability to innovate and things like that? Do you see it as a big enabler, not having to manage these big Hadoop clusters anymore, for instance?
I definitely think it is. I think it's two parts. One is exactly what you said. It's going to give people, or it's going to give organizations some headspace because they don't need, let's say, operational management teams to manage these massive instances. But on the other hand, serverless presents its own problems. I work with a lot of corporate and enterprise customers, and this is all new. So even though they have more headroom on the operational side, they now have to spend more time developing something. If you go to a client that's been using, as an example, Informatica or a Talent for a really long time, then it's easy for them to build a new job. If you say, actually, don't use that, move to this and use Lambda and Glue, it'll take them twice as long to build that job. But after a while, after that sort of learning curve has sort of stabled out, I guess that's when you get the benefits of, hey, you don't have anything to manage, and your speed of developing, I guess, new workloads is just as fast as it was before. So I think it'll take some time before we get there, but eventually get there.
Well, thanks so much for all the insights. I think it was a really super impressive, presentation on serverless data lakes. So thanks so much for joining us today, Murat.
No worries. Thank you.
Thank you. Very good. Well, that's a wrap, isn't it, Helen? What did you think about the day today?
Yeah, I've had a great time. It's been so much fun getting to know our speakers and hearing about all the cool use cases and their technology that they're using to build solutions for either their companies or their clients. It's been very cool.
Yeah, I'm just super impressed with all the innovation throughout the region. I feel like we could do a week of data presentations. Maybe we can do that next week or something like that. What do you think, producer John? Jokes. These things are an incredible amount of effort to put together, but they're super rewarding and lots of fun at the same time. I always learn a huge bunch in the process. So thank you all for coming along and being so active on the Twitch stream with all of your questions. Hope you really enjoyed it. We do have a feedback form. We want to make this as useful as possible to everyone so that you can get the most out of these days. So please do send through feedback and any comments that you might have. That'll really help us to make sure that the days are as beneficial as possible for everyone. So we're not finished. Okay, my my Siri decided to chime in there. I've just disabled that. But what I was going to say, getting back on track, is that we're not done yet with this AWS Community Day Special Edition. We've got 4 other days coming up for you. On Tuesday, we've got Alexa and Connect. IoT is coming up on Wednesday, Internet of Things, little devices sending data up to the cloud. And then we've got machine learning, and then on Thursday, and then video and AR, VR. Think of the video day on Friday as being basically us adapting to COVID. Everyone's doing live streaming and things like that. And AWS have got a great bunch of technology in that space that's super interesting. AR, VR, augmented reality, virtual reality, that's always super interesting as well. So what's happening with the Alexa and Connect Day? If you don't know, Alexa is obviously, those voice devices that we all talk to. You can create your own skills and things like that. And we've got a bunch of great speakers that will take us through that stuff. And also there's Amazon Connect, which is a cloud-based call center, if you will, that you can just spin up. And we're going to have a few talks on that. So that's going to be really cool. So our 2 hosts for tomorrow will be Kesha Williams. She's an AWS machine learning hero and Alexa course creator on A Cloud Guru. She's just awesome. She's got so many cool courses. I love watching them, and I've learned a whole bunch. which has really helped me sort of build out some cool Alexa skills. And Ian McKay, our new AWS community hero. I'm sure you've seen him around on Twitter. He's really good value. So for the day, we've got 2 Connect talks, as I mentioned, a blind low vision case study from New Zealand using Alexa technologies. That's going to be really cool. There's going to be a flash briefing skill from Emma Arrigo, and Gunnar Grosh will take us through pairing Alexa with IoT. So that's going to be awesome stuff. I'm certainly looking forward to it. So we'll see you at the same time, 11 a.m. Australian Eastern Daylight Savings Time, or GMT plus 11 tomorrow. So ciao for now.